In space, nothingness is the rule, not the exception. The vacuum between stars is so empty, even sound cannot exist. Only silence. Our bodies, made for Earth's gentle pressure, are vulnerable here. Without protection, the void's lack of pressure is instantly catastrophic, a brutal, physical force of nature.
Perfect.
In space, the cold is absolute. With no air to hold warmth, heat simply bleeds away into the void. The universe's background temperature is just 2.7 Kelvin, nearly absolute zero. Unprotected, the human body would freeze rapidly, becoming a brittle statue, a frozen monument to the universe's relentless chill. Space is a realm of extremes, freezing cold and searing heat. Stars are colossal nuclear furnaces, and without Earth's magnetic shield, their radiation is deadly. Here, our planet protects us from the sun's fury. But in open space, an astronaut faces unfiltered solar radiation and lethal temperature swings. One side scorched, the other frozen. Space is fire and ice at once. The emptiness of space is not entirely empty. It is filled with a fine dust of cosmic debris, remnants from the formation of solar systems, shattered asteroids, and the icy tails of comets. Most of these particles are no larger than a grain of sand. On Earth, they burn up harmlessly in our atmosphere, creating the fleeting beauty of a shooting star. We make wishes on them, unaware that they are bullets that our planet has taken for us. In the vacuum of space, however, these tiny particles become hypervelocity projectiles. Traveling at incredible speeds, often in excess of 20,000 miles per hour, even a minuscule fleck of paint or a grain of sand carries immense kinetic energy. It transforms from a harmless speck into a devastating weapon. A micrometeoroid of this size striking an unprotected astronaut would not simply bruise them. It would pass through them as if they were not there, carving a tunnel of vaporized tissue in its wake. The impact would be too fast to be registered, a silent, instantaneous, and utterly catastrophic event. Spacecraft and spacesuits are designed with this threat in mind. They are built with multiple layers of high-tech materials, like Kevlar and Nextel, designed to break up and absorb the energy of these tiny impacts. The windows of the International Space Station are multi-paned and incredibly thick, yet they bear the scars of countless collisions with these cosmic bullets. Each tiny pockmark is a testament to a potentially lethal impact that was successfully deflected, a reminder of the constant, invisible hailstorm that rages in the seemingly peaceful void. For a human being exposed and vulnerable, there would be no defense. The body would be perforated by thousands of these microscopic projectiles every minute, each one creating a tiny explosive wound. The cumulative effect would be a complete and total disintegration of biological integrity. It is a death by 1,000 cuts, delivered at hypersonic speeds. The serene vacuum, it turns out, is a shooting gallery, and anything unprotected within it is the target. The silence is punctuated by a constant, invisible barrage of destruction. The greatest danger of space isn't physical, it's psychological. Humans are social, grounded by the rhythms of Earth. In the void, you're utterly alone, surrounded by silence and endless blackness. The mind can fray, trapped between infinite emptiness and claustrophobic confinement. Space threatens not just the body, but the spirit. In our familiar model of the cosmos, planets are loyal companions to their stars. In our familiar model of the cosmos, planets are loyal companions to their stars. They follow predictable, elliptical paths, held in a gravitational embrace that has persisted for billions of years. This is the architecture of our own solar system, a stable and orderly family of worlds orbiting a central sun. We see this as the natural state of affairs, the way planetary systems are meant to be. This vision of cosmic order provides a sense of stability, a belief that the heavens operate with a clockwork precision that we can understand and predict. But the universe is far more chaotic and dynamic than our tidy local model suggests. In the turbulent nurseries where stars and planets are born, gravitational interactions are violent and unpredictable. Young planets jostle for position, their orbits shifting and changing as they tug upon one another. In this gravitational billiards game, not every world finds a stable home. Many are ejected, flung out of their nascent solar systems with tremendous force, destined to wander the interstellar darkness alone. These are the rogue planets, the cosmic orphans. They are not bound to any star, slaves to no gravitational master. They drift through the vast, empty gulfs between the stars, enshrouded in a perpetual night. Their existence was once purely theoretical, a ghostly prediction of planetary formation models. But now, through subtle gravitational effects on the light of distant stars, we have begun to detect them. We are just beginning to understand how common these lonely wanderers might be. Current estimates are staggering. For every star you see in the night sky, there may be dozens or even hundreds of these rogue planets drifting silently in the abyss. Our galaxy could be teeming with them, a hidden population of dark worlds outnumbering the stars themselves. They are a shadow inventory of the cosmos, a testament to the chaotic violence of creation. They travel not in neat orbits, but on random, unbound trajectories through the Milky Way, their paths intersecting our own stellar neighborhood completely by chance. A rogue planet is a world of endless night, frozen and drifting through the darkness of space. Its surface is locked in perpetual cold with only faint starlight above. Yet deep below, internal heat could sustain a hidden ocean. Life might thrive there, clustered around vents, never knowing the sun. A rogue planet, an unseen cradle of life lost in eternal night. The most unsettling aspect of rogue planets is their stealth. Because they emit no light of their own, and are far from any star to reflect light, they are practically invisible. They are the ultimate cosmic ghosts, moving through the galaxy almost completely undetected. Our current methods for finding planets rely on observing their effects on a parent star, either the dimming of starlight as a planet passes in front, or the slight wobble a planet's gravity induces in its star. A rogue planet offers neither of these telltale signs. The only way we can currently spot them is through a phenomenon called gravitational microlensing. When a rogue planet passes directly in front of a distant star from our perspective, its gravity acts like a lens, briefly bending and magnifying the star's light. This effect is tiny, transient, and requires perfect alignment, meaning we only ever see a tiny fraction of the rogues that are out there. For every one we detect through this fleeting method, thousands upon thousands more slip by completely unnoticed. This means that a rogue planet could, in theory, pass through our own solar system, and we might not know it was here until it was already deep within our planetary neighborhood. It would not announce its arrival with a bright light in the sky. It would be a dark, cold mass, moving silently out of the interstellar void. Its presence would only be revealed by its gravitational influence on the objects around it, the subtle and then not-so-subtle tug on our outer planets, comets, and asteroids. The chances of a direct collision with Earth are infinitesimally small, given the sheer volume of space. But a direct impact is not the only danger. The true threat of a rogue planet is gravitational. A large planet, a gas giant many times the mass of Jupiter, wandering through the outer solar system would be a cosmic wrecking ball. It wouldn't need to hit anything to cause unimaginable chaos. Its immense gravity would be a disruptive force, a phantom hand stirring the delicate architecture of our solar system. Imagine a world larger than Jupiter, a dark and cold giant, silently gliding through the Oort cloud, the vast distant sphere of icy comets that surrounds our solar system. Its powerful gravity would act like a shepherd's crook, flinging trillions of these comets out of their stable, distant orbits. A significant number of them would be sent hurtling into the inner solar system, creating a celestial bombardment on a scale unseen in human history. Earth would face a rain of cometary impacts lasting for centuries, any one of which could be a civilization-ending event. This would be a profound and devastating disruption of our cosmic peace. The night sky, once a symbol of tranquility, would become a terrifying spectacle of incoming fire. The rogue planet itself might remain unseen, its passage marked only by the deadly swarm of comets it had unleashed upon us. It would be a ghostly assailant, an invisible perpetrator that had disturbed a hornet's nest at the edge of our home and then continued on its lonely journey, oblivious to the chaos it had left in its wake. If the rogue planet were to pass even closer, through the Kuiper belt where Pluto resides, its effects would be even more severe. The orbits of dwarf planets and large asteroids would be twisted and deformed. Neptune and Uranus, our ice giants, could be pulled into new, unstable orbits, threatening the stability of the entire system. The delicate gravitational dance of our solar system, a balance perfected over 4.5 billion years, would be thrown into complete disarray. And in the most extreme yet still possible scenario, the passage of a massive rogue could even affect the orbits of the inner planets, including our own. A close pass by a Jupiter mass rogue could potentially alter Earth's orbit, pushing us closer to or farther from the Sun. Either outcome would be catastrophic, leading to a runaway greenhouse effect or a permanent ice age. The planet itself would survive, but the delicate conditions that allow for our existence would be shattered forever by this silent, wandering interloper. The existence of rogue planets introduces a profound element of randomness and unpredictability into the cosmic order. You know, we like to think of our solar system as a safe harbor, an island of stability in the vastness of space. But the knowledge that there are potentially billions of unseen worlds wandering the galaxy on chaotic trajectories, well, it really shatters this illusion. It means that at any time, without any warning, a catalyst for immense destruction could be silently approaching our home. This is not a threat that we can prepare for or defend against in any meaningful way. Honestly, we cannot build a shield against the gravity of a world many times the mass of our own. We cannot hope to alter the course of an object that has been traveling on its path for eons. The timescales and energies involved are simply beyond our comprehension and our technological capabilities. We are, in this sense, completely at the mercy of a cosmic lottery. The passage of a rogue planet through our solar system is undoubtedly a low-probability event. The space between stars is immense, and the chances of such a close encounter in any given millennium are small. However, over the vast timescales of geology and cosmology, the improbable becomes almost inevitable. Our solar system has likely had close encounters with such wanderers in its distant past, events that may have shaped its very formation and the history of life on Earth. And so we are left with a chilling thought. Every night, when we look up at the familiar constellations, we are staring into a darkness that is not as empty as it seems. It is populated by a hidden multitude of cold, dark worlds. We are adrift in a galaxy that is not just a collection of stable, well-behaved star systems, but also a shooting gallery of planetary nomads. The silence of space may not be empty, but pregnant with the approach of these lonely and potentially devastating wanderers. Across the unimaginable vastness of the cosmos, a drama of immense scale and ferocity unfolds, largely unseen by human eyes. Across the vastness of the cosmos, the universe unleashes its most violent outbursts, gamma-ray bursts, or GRBs. In seconds, these cosmic explosions release more energy than our sun will in its entire lifetime. GRBs are the death cries of massive stars or the violent mergers of stellar corpses. Their energy is focused into narrow, unstoppable jets of gamma rays, slicing through space. Any planet caught in their path faces instant apocalyptic destruction, a stark reminder of the universe's raw power. Gamma-ray bursts are the universe's silent executioners. Unlike asteroids, they travel at light speed, no warning, no escape. The sky ignites, the ozone layer shreds, and life is devastated in seconds. A cosmic catastrophe unfolding without a sound, leaving Earth forever changed. Hypernovae, explosive deaths of massive Wolf-Rayet stars, unleash focused jets of destruction across the cosmos. These narrow beams are mostly harmless, but if aimed at us, they become planet-killing spears of radiation. Some scientists believe a gamma-ray burst may have triggered a mass extinction on Earth. In this cosmic firing squad, we're playing roulette with the universe's deadliest weapons. In our own galaxy, WR 104, a massive Wolf-Rayet star, could unleash a devastating gamma-ray burst. For years, scientists feared its axis might point toward Earth, threatening an extinction-level event. Recent observations suggest we're likely safe, but WR 104 remains a powerful reminder of our cosmic vulnerability. Gamma-ray bursts are a chilling, inescapable hazard of our universe, natural yet terrifying. The same cosmic forces that create life can also destroy it in an instant. There's no shield we can build. Our atmosphere is our only defense, and it would be the first to fall. We are fragile, adrift in a vast, indifferent cosmos. Life, precious and rare, always living on borrowed time. Across the vast, sprawling tapestry of the cosmos, there exist regions of such profound mystery and terror that they defy our most fundamental understanding of reality itself. Across the vast cosmos, there exist regions of such profound mystery and terror that they defy our understanding of reality. We call them black holes, points of no return, where gravity is so powerful it tears the fabric of space-time. Born from the death of colossal stars, they crush matter to a point of infinite density. The event horizon marks a one-way door to oblivion. Nothing, not even light, escapes. Black holes are the ultimate embodiment of cosmic dread, a final, dark destination from which there is no return. The event horizon is an invisible boundary, drawn by the immense gravity of a black hole's singularity. Here, gravity is so strong that not even light can escape. To a distant observer, anything falling in appears to freeze and fade at the edge, never truly crossing. Once crossed, escape is impossible. Only a relentless pull toward the singularity remains. The event horizon stands as a silent monument to the limits of our understanding. Spaghettification is the horrifying process that occurs when something crosses a black hole's event horizon. The immense tidal forces stretch objects into long, thin strands, like cosmic spaghetti. For a human, every cell would be pulled apart, unraveling into a stream of atoms. It's the universe's ultimate act of destruction, matter erased by the raw power of a black hole. While stellar mass black holes are terrifying, the universe has produced predators on a far grander scale. At the heart of almost every large galaxy lurks a supermassive black hole, millions or billions of times more massive than our Sun. Our own, Sagittarius A*, is a calm giant with the mass of 4 million suns. When active, these monsters become the brightest objects in the cosmos, shaping galaxies and humbling us all. Black holes are the ultimate cosmic stealth, emitting no light, no heat, no warning. Drifting silently, they can only be detected by their gravitational pull on nearby stars or the rare bending of starlight. The greatest dangers in our universe are often those we cannot see, lurking, silent, and invisible. The universe as we know it is a place of breathtaking energy and dynamism. The universe dazzles with the light of countless stars, each a nuclear furnace shaping the cosmos. But this brilliance is not eternal. Over unimaginable time, stars will fade and die, plunging the universe into darkness. What follows is a cold, empty void. The final silent chapter of the cosmic story. After the last star has extinguished its light, the universe will enter what is known as the degenerate era. This epoch will be dominated by the remnants of stars, the so-called degenerate objects. White dwarfs, the dense cores of sun-like stars, will drift through the darkness like cosmic diamonds, slowly cooling over quadrillions of years until they become black dwarfs, cold, inert spheres of crystallized carbon and oxygen. Neutron stars, the incredibly dense relics of supernovae, will also cool and fade, their immense magnetic fields slowly decaying over time. Black holes will be the undisputed rulers of this dark age. They will continue their slow, patient work of consuming any matter that drifts too close. Over vast timescales, galactic structures will completely dissolve. The gravitational interactions between the stellar remnants will eventually fling most of them out into the lonely intergalactic void. A few will be captured by the central supermassive black holes, feeding them and allowing them to grow ever larger. The universe will become a far emptier, more desolate place than it is today. Life as we know it, based on the energy from stars, will be an impossibility. Any civilization that might have survived the end of the stelliferous era would have to find new sources of energy to stave off the encroaching cold. Perhaps they could harness the rotational energy of black holes or the slow decay of matter itself. But even these sources are finite. The struggle for survival would be a battle against the inevitable, a desperate attempt to gather the last few crumbs of energy from a universe that is systematically shutting down. The timescales involved in this era are so vast they beggar belief. We are talking about periods lasting trillions upon trillions of years, a length of time so great that the entire 13.8 billion year history of our universe so far would be less than an eye blink in comparison. It is an era of profound stillness and decay, where the only significant events are the slow evaporation of stellar remnants and the occasional final meal of a patient black hole. Even black holes, once thought eternal, slowly evaporate through Hawking radiation. Stephen Hawking revealed that black holes emit faint particles, losing mass over unimaginable timescales. As they shrink, their temperature rises, ending in a final flash of energy. When the last black hole evaporates, the universe enters the dark era. All that remains is a cold, empty universe, true heat death, a void without end. The arrow of time is shaped by the universe's increasing entropy, giving time its direction, from the Big Bang to a cold, dark future. When maximum entropy is reached, time itself may lose all meaning. The universe could end in perfect, eternal quiet, a timeless, featureless expanse. Let us try, for a moment, to truly contemplate this final state. It is a future not of years or centuries or even millennia, but of an eternity measured in numbers so large they defy notation. The universe will be an unimaginably vast, dark, and empty space expanding forever. The temperature will hover just fractions of a degree above absolute zero, the theoretical point at which all atomic motion ceases. Any remaining particles will be so far apart that interactions between them will be practically non-existent. The very concept of place will become nebulous. Without stars or galaxies to act as landmarks, the universe will be a homogeneous, featureless void. There will be no light, no heat, no sound, no structure, only an endless, silent, and cold expanse stretching on for infinity. It is the ultimate isolation, the ultimate solitude. The grand cosmic experiment, which began with the incredible energy and density of the Big Bang, will have concluded in the most understated and final way imaginable. This fate, the heat death, is perhaps the most existentially terrifying of all the cosmic horrors. It is not a sudden, violent end, but a slow, grinding, and inevitable decay into nothingness. It suggests that all the complexity, all the beauty, all the life that has arisen in the universe is merely a temporary and fleeting phenomenon, a brief, flickering candle in an eternal, encroaching darkness. All of our struggles, our achievements, our art, and our science will ultimately be rendered meaningless, erased by the relentless march of entropy. It is a conclusion that strikes at the very heart of our search for purpose. It forces us to confront the possibility that the universe has no grand design, no final goal other than this slow descent into cold, dark equilibrium. The vibrant cosmos we observe today is but a fleeting moment of warmth and light in an infinite timeline of cold and dark. The energy that drives our world is a finite inheritance, and one day the inheritance will run out, leaving only an eternal, silent, and frozen tomb. Tonight, we've glimpsed the universe's darkest truths, the lethal vacuum of space, rogue planets, gamma-ray bursts, black holes, and the cold fate of heat death. These are reminders of our fragility, adrift on a blue marble in a vast, mysterious cosmos. So after all this, are you still sure you want to look? Beyond our blue and green world lies a vast, silent theater, the solar system where planets dance in a cosmic ballet. For millennia, we've gazed upward, charting the heavens and dreaming of distant worlds. Now join us as we embark on a journey to witness the 8 wonders of our solar system. Jupiter, the king of planets, is a colossal gas giant whose swirling clouds and ferocious winds create a world of unparalleled scale and power. Amidst this chaos lies the Great Red Spot, a storm wider than Earth, raging for centuries, its winds howling at over 400 kilometers per hour. This colossal crimson enigma is a living reminder of the alien and extreme nature of our planetary neighbors. Jupiter's Great Red Spot is a colossal storm, swirling within powerful jet streams. Smaller storms are swept along its edge, sometimes consumed by its might. The spot's boundary is a region of extreme turbulence, where order and chaos blend. It towers above the clouds, a spinning pillar of gas, an enduring, mysterious masterpiece of planetary weather. The Great Red Spot remains shrouded in mystery. Once large enough to fit 3 Earths, it's now shrinking, its fate uncertain. Is this a natural cycle, or the storm's final days? Scientists watch closely, as this iconic Jovian tempest reminds us that even the grandest features in our solar system are not eternal. Mars, the red planet, is home to Olympus Mons, the largest volcano and mountain in our solar system. Its vast, gentle slopes rise 25 kilometers above the plains, nearly 3 times the height of Everest. Olympus Mons towers above the Martian landscape, a silent testament to Mars's unique geology and low gravity. At the summit of Olympus Mons lies a vast caldera, an immense volcanic depression, not an impact crater, but the collapsed roof of an ancient magma chamber. Cliffs drop away for kilometers, revealing the volcano's explosive history. At its base, a massive escarpment rises, possibly shaped by landslides or ancient Martian seas. These features hint at a time when Mars may have been blue, with water, atmosphere, and perhaps life. Olympus Mons, the largest volcano in the solar system, is a sleeping giant. Though dormant now, its recent lava flows hint at activity just 2 million years ago, a blink in geological time. Some scientists believe magma may still linger deep below, making Olympus Mons a silent monarch, holding Mars's fiery secrets. Here, in the cold, silent theater of the outer solar system, hangs a spectacle of unparalleled grandeur. Saturn, the 6th planet from our Sun, is adorned with a system of rings so vast and intricate that they defy simple description. They are not solid structures, but a swirling collection of countless particles. Each fragment, from dust to mountains, is a tiny moon in a gravitational ballet. This cosmic halo, stretching almost 280,000 kilometers, is a testament to the delicate balance of forces. Gravity holds this immense disk in place, yet it is surprisingly fragile. The entire system is astonishingly thin, no more than a few tens of meters. This incredible thinness makes their sheer breadth all the more remarkable. The particles are almost entirely water ice, giving the rings their ethereal glow. This glow makes Saturn a luminous beacon in the night sky. Woven within this icy tapestry are subtle impurities, painting the rings in delicate hues. Shades of cream, pinks, and browns reveal different chemical histories. How did such a structure come to be? The leading theory suggests a dramatic and violent past. Perhaps a moon, venturing too close to Saturn, was torn asunder. Or maybe a comet met its end in a catastrophic collision. The resulting debris was smeared out into this magnificent orbiting disk. The rings are a ghostly remnant of a world that once was, a perpetual memorial to a long-lost cosmic sibling. Saturn's rings are shaped by the gravitational pull of its many moons. These celestial shepherds carve gaps, confine the edges, and create ever-shifting patterns. The F ring, for example, is shaped by tiny moons, Prometheus and Pandora. Even hidden moonlets leave propeller-like marks, revealing a dynamic living system. Saturn's rings are a celestial ballet, a river of ice, forever shaped by the dance of moons. The rings of Saturn are a fleeting phenomenon on a cosmic timescale. They may be a recent addition, forming during the age of the dinosaurs. Their brightness suggests youthfulness. The rings are slowly disappearing. A gentle rain of particles is being pulled inwards by Saturn's gravity. Cassini data shows the rings are losing mass rapidly. We are witnessing Saturn in its full, magnificent glory. The rings remind us of the transient nature of cosmic beauty. Far from the Sun, in the frigid domain of Saturn, orbits a small, unassuming moon. At just 500 kilometers in diameter, Enceladus is a tiny world. So small, it could fit comfortably within the borders of Great Britain. For centuries, it was little more than a faint point of light in our telescopes, one of dozens of moons orbiting the ringed giant. It is covered in a shell of brilliant white ice, making it one of the most reflective objects in our entire solar system. Its surface, we thought, was a static, frozen wasteland, locked in a deep and unchanging slumber. But as our robotic explorers drew closer, they revealed a world of shocking and unexpected activity. The southern polar region of Enceladus is unlike anything else we have ever seen. It is not a landscape of ancient dead craters, but one of youthful dynamic geology. Crossing this region are 4 enormous parallel fissures, dubbed tiger stripes. These are colossal cracks in the moon's icy crust, each over 100 kilometers long. They are warmer than the surrounding terrain, radiating a faint heat from somewhere deep within this tiny, frozen world. And from these stripes, something extraordinary emanates. Great plumes of water vapor and ice crystals are continuously erupting from the moon's interior, blasting hundreds of kilometers out into the vacuum of space. These are cryovolcanoes, or ice geysers, a phenomenon so alien it challenges our understanding of how such a small, cold world can be so geologically active. Enceladus is not dead, it is alive, breathing out its internal ocean into the cosmos, a tiny moon with a mighty secret hidden beneath its placid, icy surface. This continuous eruption of material is the source of one of Saturn's own rings. The faint, diffuse E-ring, the outermost of the planet's main rings, is composed almost entirely of the fine ice particles expelled from Enceladus. This tiny moon, a mere speck in the Saturnian system, is single-handedly creating a structure that encircles its giant parent planet. It is a profound connection, a small world actively shaping its local environment on a planetary scale, a testament to the surprising power hidden in the most unlikely of places. The existence of these magnificent plumes points to an astonishing conclusion. Beneath the frozen crust of Enceladus, there must be a vast reservoir of liquid water. The sheer volume of material being ejected into space can only be sustained by a large, subsurface ocean. The heat signatures along the tiger stripes, the composition of the plumes themselves, it all points to a liquid interior. This tiny, icy moon, so far from the warmth of the sun, holds one of the most sought-after ingredients for life as we know it, a stable body of liquid water. But how can liquid water exist so far from the sun, where surface temperatures plummet to -200 degrees Celsius? The answer lies in a gravitational tug-of-war. Enceladus is locked in an orbital dance with Saturn and a larger neighboring moon, Dione. This complex resonance causes Enceladus's orbit to be slightly elliptical. As it moves closer to and then farther from Saturn, the planet's immense gravity constantly squeezes and stretches the little moon. This process, known as tidal heating, generates immense friction deep within its core, creating the heat needed to keep its hidden ocean from freezing solid. The Cassini spacecraft, in a series of daring fly-throughs, plunged directly through these plumes to sample their composition. What it found was astounding. The plumes are not just water ice. They contain simple organic compounds, molecules like methane and formaldehyde, the fundamental building blocks of life. They also contain salts and silica dust, evidence that the ocean is not isolated, but is in direct contact with a hot, rocky core at the moon's center. It is a chemical environment eerily similar to that found around hydrothermal vents on Earth's own ocean floors. This discovery has transformed Enceladus from a curious spectacle into one of the most compelling locations in the solar system to search for extraterrestrial life. We have found all the necessary ingredients in one place: liquid water, a source of energy from tidal heating, and the basic organic chemistry needed to build living organisms. It is a cosmic recipe for life, hidden beneath a shell of ice just waiting to be explored. A tiny moon, once thought to be inert, may in fact be one of the most habitable environments beyond our own world. The plumes of Enceladus serve as a direct conduit to this hidden, potentially life-bearing world. They offer us a unique opportunity, a free sample of a subsurface alien ocean delivered directly into space. We do not need to land and drill through kilometers of solid ice, which honestly would be a monumental engineering challenge. Instead, we can simply fly through these geysers and collect the material that the moon itself is offering up. It's a remarkable gift from nature, an invitation to probe the secrets of its deep interior without ever touching its surface. Future missions are already being designed with this in mind. Spacecraft equipped with more advanced instruments could analyze the plume material with far greater sensitivity, searching for the complex organic molecules, the amino acids and lipids, that could be the telltale biosignatures of life. They could search for evidence of metabolic processes, those chemical imbalances that living organisms create in their environment. The plumes of Enceladus are not just a geological wonder, they are a signpost, pointing the way towards answering one of humanity's oldest and most profound questions. The implications are, well, absolutely staggering. If life could arise in a dark ocean, warmed by tidal forces, so far from a star, it would mean that the conditions for life are far more common in the universe than we ever dared to imagine. It would suggest that habitable zones are not just defined by proximity to a sun, but can be created by the gravitational interactions between worlds. Moons, not just planets, could be the most common abodes for life in the cosmos. Enceladus represents a paradigm shift in our search for life elsewhere. And so, this small, bright moon has become a beacon of hope and possibility. From its unassuming appearance, it has revealed itself to be one of the most dynamic and exciting worlds in our solar system. Its icy geysers are more than just a beautiful spectacle. They are a window into a hidden realm, a potential cradle of life that challenges our preconceptions and expands our imagination. Enceladus reminds us that even in the coldest, darkest corners of space, the universe can harbor warmth, water, and the profound potential for life. At the North Pole of Saturn, there exists a weather pattern so strange, so perfectly geometric, that it appears to be a work of intelligent design. It is a colossal six-sided storm, a hexagon of swirling clouds large enough to contain 4 Earths within its boundaries. Nothing like it has ever been seen on any other planet in our solar system. It is a feature that, honestly, just defies our conventional understanding of atmospheric physics. A meteorological enigma that has puzzled scientists since it was first glimpsed by the Voyager spacecraft in the early 1980s. This is not a fleeting cloud formation. The hexagon is a remarkably stable and persistent feature, a standing wave in Saturn's atmosphere that has been raging for decades, possibly centuries. At its center, a vast polar vortex spins with ferocious intensity, a hurricane larger than any on Earth. But surrounding this central eye is the hexagon itself. Its 6 straight sides, each longer than the diameter of our own planet, rotating in lockstep with the planet's own rotation. The precision of its form is utterly baffling. Storms on Earth are chaotic and unpredictable. This storm is a masterpiece of geometric order. The sheer scale of this phenomenon is, well, difficult to comprehend. The winds that form the walls of this hexagonal jet stream howl at over 300 kilometers per hour, creating a powerful barrier that isolates the atmospheric conditions inside the hexagon from those outside. This has led to the formation of a distinct haze within the six-sided shape, a different chemical soup from the rest of the polar region. The hexagon is not just a shape, it is a self-contained weather system, a vast atmospheric island with its own unique climate. How can nature, which so often favors curves and spirals, create such a perfect geometric shape on such a colossal scale? The forces at play are immense, involving the rapid rotation of the planet, deep convective currents, and the complex fluid dynamics of Saturn's hydrogen and helium atmosphere. Yet the precise mechanism that locks this storm into such a stable, six-sided pattern remains a subject of intense scientific debate. It is a perfectly formed mystery, a geometric giant that challenges the very limits of our atmospheric models. At the very heart of this vast hexagonal structure lies another, equally mesmerizing feature, a gigantic polar hurricane. This vortex, some 2,000 kilometers across, is the eye of the storm, a swirling abyss of descending air that plunges deep into the planet's atmosphere. The winds at the edge of this eye wall are truly terrifying, reaching speeds of over 500 kilometers per hour, more than twice as fast as the winds in the most powerful Category 5 hurricanes on Earth. It is a storm of unimaginable violence and power. Unlike hurricanes on Earth, which are powered by warm ocean water and last for mere weeks, this Saturnian superstorm has no ocean to feed it. It is powered by the planet's own internal heat, a remnant of its formation billions of years ago. There are no continents to break it up, no landmass to slow its progress. And so it rages on year after year, decade after decade, a permanent fixture of the planet's North Pole. It is a storm for the ages, a vortex that may have been spinning long before human civilization began. Observations from the Cassini spacecraft have revealed stunning details within this central vortex. The eye itself is surprisingly clear of clouds, allowing us to peer deep into the lower layers of Saturn's atmosphere. The clouds that form the towering eye wall are tinted a strange, reddish-brown, a color not seen elsewhere in the hexagon, suggesting a unique chemical process is occurring within this violent crucible. It is a storm with its own distinct personality, its own colors, and its own mysterious chemistry, all contained within the geometric confines of the hexagon. The motion within the storm is a captivating spectacle. Small, bright clouds can be seen being swept along by the ferocious winds, circling the central eye in a matter of hours. They are like small boats caught in a colossal whirlpool, tracers that allow us to witness the raw power of this polar vortex. The entire system, the hexagon and its central hurricane, rotates as a single, coherent entity, a vast and complex piece of atmospheric machinery spinning at the top of a world, a testament to the extreme and beautiful physics of giant planets. The hexagon is more than just a scientific curiosity. It is, honestly, a unique natural laboratory for studying the behavior of fluids. Scientists on Earth have been able to recreate similar, though much smaller, hexagonal patterns in laboratory settings. By spinning a circular tank of liquid at different speeds at its center and periphery, they can generate standing waves that lock into stable geometric shapes, including hexagons. This suggests that the Saturnian storm is a manifestation of fundamental principles of fluid dynamics, occurring on an almost unbelievable scale. These experiments provide a compelling clue. They suggest that the hexagon is formed by a steep gradient in wind speeds within Saturn's atmosphere. A powerful jet stream, flowing eastward at a specific latitude, is being perturbed by other atmospheric waves, causing it to meander. Under just the right conditions of speed and latitude, this meandering path can lock into a stable, resonant pattern with 6 distinct peaks and troughs. The hexagon, then, is a wave made visible, a pattern frozen in the clouds of a rapidly spinning world. The changing seasons on Saturn, each lasting more than 7 Earth years, have a profound effect on the hexagon. As the northern hemisphere tilted towards the sun during Cassini's long mission, the hexagon changed color, shifting from a cool blue to a golden haze. This change is thought to be caused by photochemical reactions, as sunlight interacts with the atmospheric gases that have been trapped inside the hexagon for decades. The storm is not static. It is, in fact, a living, breathing system that responds to the slow, stately rhythm of the Saturnian year. Ultimately, the hexagon storm on Saturn stands as a powerful symbol of the universe's capacity to produce order and complexity in the most unexpected ways. It is a fusion of chaos and geometry, a violent storm held within a structure of perfect mathematical elegance. It reminds us that the laws of physics can create patterns of breathtaking beauty and scale, far beyond anything we could engineer ourselves. It is a natural wonder that continues to inspire awe and drive our quest to understand the intricate workings of the worlds beyond our own. At the edge of the sun's reach, Neptune glows a mesmerizing blue, an ice giant 30 times farther from the sun than Earth. Its color comes from methane, scattering sunlight into vibrant blues. But beneath this calm, Neptune's atmosphere rages with the fastest winds in the solar system. The Great Dark Spot, seen by Voyager 2, revealed the planet's wild, untamed power. To truly understand Neptune, we must journey deeper, past the wind-scoured upper atmosphere and into the planet's mysterious interior. Unlike the gas giants Jupiter and Saturn, which are composed almost entirely of hydrogen and helium, Neptune and its neighbor Uranus are classified as ice giants. This name alludes to their very different internal composition, a layered structure that sets them apart. The outer atmosphere, rich in hydrogen and helium, eventually gives way to a far denser, more substantial region below a place of immense pressure and exotic states of matter. This inner realm consists of a hot, dense fluid mixture of water, methane, and ammonia ices. These are not ices in the familiar solid sense we know on Earth. Instead, under the crushing pressures and high temperatures found deep within Neptune, these compounds exist in a strange, supercritical fluid state, behaving like a vast, sloshing planetary ocean. This super-pressurized mantle is thought to be where much of the planet's internal heat is generated, possibly through the slow gravitational contraction of the planet itself, a remnant warmth from its formation billions of years ago. Deeper still, scientists theorize the existence of a truly remarkable phenomenon, a rain of diamonds. In the extreme conditions of the mantle, the immense pressure could be sufficient to squeeze the carbon atoms out of the methane molecules, compressing them into solid diamond crystals. These precious gems, heavier than the surrounding fluid, would then slowly rain down through the mantle, settling towards the planet's core over thousands of years. It is a staggering thought, a planet where glittering jewels fall like hail through a dark, turbulent ocean of superheated ice. At the very center of this layered world lies a core thought to be roughly the size of Earth itself. This core is likely composed of rock, metal, and ice, a solid foundation under tens of thousands of kilometers of compressed gas and fluid. The pressure here is millions of times greater than at sea level on Earth, and the temperatures soar to thousands of degrees Celsius, hotter than the surface of the sun. It is this small, superheated engine that drives the planet's extreme weather, radiating more than twice the energy it receives from the distant sun, powering the colossal winds that rage across its blue face. Neptune's gravitational influence extends far beyond its cloudy atmosphere, holding in its sway a diverse and curious family of at least 14 moons. These are not a uniform collection of worlds formed in place, but rather a motley crew of captured objects and remnants of ancient collisions. Each moon tells a piece of the story of the outer solar system's chaotic history. They range from tiny, irregularly shaped rocks just a few tens of kilometers across, to the seventh largest moon in the entire solar system, the strange and captivating Triton. Triton is by far the most fascinating of Neptune's companions. It is a world locked in a retrograde orbit, meaning it circles the planet in the opposite direction to Neptune's own rotation. This is a telltale sign that Triton did not form alongside Neptune, but was once a free-orbiting dwarf planet, much like Pluto, that was snared by the ice giant's gravity billions of years ago. This violent capture would have wreaked havoc on Neptune's original satellite system, flinging moons into new orbits or casting them out into space entirely, leaving Triton as the dominant and ultimately doomed captured prize. This captured world is one of the coldest objects ever measured in our solar system, with surface temperatures plummeting to -235 degrees Celsius. Its surface is a stunning mosaic of frozen nitrogen, water ice, and carbon dioxide, creating vast smooth plains and a cantaloupe-like terrain of intersecting ridges and valleys. Most remarkably, despite the extreme cold, Triton is geologically active. Voyager 2 captured images of dark plumes erupting from its surface, geysers of nitrogen gas and dark dust particles soaring up to 8 kilometers into its extremely thin atmosphere before falling back to the surface. The story of Triton and Neptune is a cosmic dance with a definitive end. Because of its retrograde orbit, Triton is slowly spiraling inwards towards the planet. Tidal forces are relentlessly pulling it closer, and in a few 100 million years, it will reach a critical point known as the Roche limit. Here, Neptune's gravitational pull will become stronger than Triton's own internal gravity, and this magnificent icy moon will be torn apart. Its fragments will form a spectacular new ring system around Neptune, one that could rival the grandeur of Saturn's, a final glittering monument to a lost world. Orbiting Jupiter is Io, a moon unlike any other. Io is the most volcanically active world in our solar system, its surface constantly reshaped by eruptions. Its landscape is painted in vivid colors by sulfur from deep within. This fiery activity is driven by a gravitational tug-of-war with Jupiter and neighboring moons. To study Io is to witness planetary geology in action, a world forever forged in fire. Among Io's hundreds of volcanoes, Prometheus and Loki stand out as titanic monuments to its inner turmoil. Prometheus is a persistent volcanic field, its plume creating bright circular sulfur rings on the surface. Even more immense is Loki Patera, a vast, overturning lava lake, larger than Lake Ontario. These features are not just curiosities, but windows into extreme volcanism, revealing the power within planetary bodies. The vibrant, almost lurid colors that define Io are a direct consequence of its extreme volcanism. They are the chemical palette of sulfur and its various compounds, transformed by the incredible range of temperatures found across the moon's surface. The yellows, oranges, and reds are all different allotropes, different structural forms, of elemental sulfur. The hottest regions, where fresh lava at over 1,000 degrees Celsius erupts onto the surface, appear black and dark red. As this material spreads and cools, it transitions through a spectrum of colors, creating the mottled, pizza-like appearance that so startled scientists when first observed. This sulfur cycle is a dynamic and planetary-scale process. Sulfur dioxide gas, the primary component of the volcanic plumes, freezes into a brilliant white frost in the colder regions of Io, covering vast plains in a layer of what looks like snow. But this is a fragile and temporary covering. When heated, even gently by the weak sunlight or by underlying geothermal activity, this sulfur dioxide frost can sublimate directly back into a gas, leaving the darker, more colorful sulfur deposits exposed beneath. This constant interplay of deposition and sublimation adds another layer of complexity to Io's ever-changing face, a world perpetually repainting itself. The influence of Io's volcanism extends far beyond its own surface. The material ejected from its plumes, traveling at high velocity, is not all recaptured by the moon's weak gravity. A significant portion escapes into space, forming a vast donut-shaped cloud of plasma that surrounds Jupiter, known as the Io plasma torus. This torus is composed of ionized atoms of sulfur, oxygen, sodium, and potassium, all stripped from Io's atmosphere and surface by Jupiter's powerful magnetic field. It rotates along with the giant planet, glowing faintly in ultraviolet light, a vast, invisible structure energized by the planet's magnetosphere. This constant feeding of the torus makes Io a powerful engine within the Jovian system, shaping the magnetic and radiation environment for vast distances around it. The energetic particles within this plasma torus are responsible for some of the most intense aurorae seen anywhere in the solar system, both on Jupiter itself and, remarkably, creating an electrical footprint back on Io's own atmosphere. This tortured moon is not an isolated object, but is intimately and violently connected to its parent planet, a key component in a complex and dynamic system, its volcanic heart pumping life, or at least material, into the space around it. On Mars lies Valles Marineris, a canyon system so vast it dwarfs any on Earth. Stretching over 4,000 kilometers, it would span the United States. This monumental scar was forged by tectonic forces, not rivers. Valles Marineris is a testament to Mars's violent geological past. Valles Marineris is a vast Martian canyon, a labyrinth of intersecting valleys, towering chasms, and ancient rock layers. Its fractured terrain and layered sediments hint at a dynamic past, perhaps once shaped by water. This canyon is not just a scar, but a window into Mars's deep and complex history. Valles Marineris holds echoes of a wetter Mars. Tributary canyons and gullies shaped by ancient water branch from its walls. Waterfalls may have once plunged over its rims, rivers meandered across its floor. Today, the canyon is silent, but its walls and valleys preserve the memory of a dynamic, water-rich world. Our journey through the wonders of our solar system comes to a close. From Jupiter's great red spot to the icy plumes of Enceladus, each world reveals nature's boundless imagination. These marvels remind us that the cosmos is filled with beauty and mystery, waiting to be explored. The adventure has only just begun. Come with me, let's journey to our cosmic neighborhood. We see it every night, the moon, a loyal companion. We've even sent robotic emissaries to walk upon their surfaces. Are we ready to look deeper? Prepare to be stunned by the solar system's wildest secrets. It is a dynamic, violent, and utterly strange place. It's a place where it rains precious gems, where worlds are cooked alive. These aren't tales of science fiction. They are the startling truths. We will travel from the crushing depths of gas giants to the scorching surface of our nearest planetary neighbor, and the sheer, unadulterated wonder of the universe we are privileged to inhabit. So, strap in. Our voyage begins now. We are the sentient observers who can finally begin to read its chapters. Our destination, the outer solar system, the realms of Jupiter and Saturn. From Earth, they appear as majestic jewels. Jupiter, adorned with swirling clouds and its great red spot, a storm larger than Earth. Saturn, the ringed wonder, an icon of celestial beauty. These are not gentle giants, but worlds of unimaginable power. Imagine plunging into their atmospheres. Descending through layers of hydrogen and helium clouds, the pressure builds relentlessly. Here, familiar materials behave in alien ways. The key ingredient, carbon. In Jupiter and Saturn's atmospheres, it exists as methane gas. Colossal lightning storms shatter the methane, freeing carbon atoms for a transformative journey downward, pulled by immense gravity, pressure, and temperature climb. The destination, a precious state of matter. The soot is becoming crystal. The journey downward continues into the heart of the storm. The pressure mounts, squeezing the falling carbon soot. Under this titanic compression, the soot begins to change, their bonds rearranging into a more stable, more organized form. The black soot is compressed into graphite. The rain of graphite continues its fall. The temperature is thousands of degrees Celsius. The intense pressure forces the carbon atoms into a rigid, interlocking crystal lattice. This is the moment of creation. It has become a diamond. We are talking about a continuous, planet-wide rain of diamonds, falling through a sky you could never see, on a world you could never visit. Scientists estimate that the process could be creating as much as 1,000 tons of diamonds every single year on Saturn alone. They continue their descent toward an even stranger fate. The diamond hailstones, as large as your fist, continue their plunge through the deep atmosphere. Approaching the planet's deep interior, they encounter extreme conditions. The solid diamond crystals melt into liquid. Imagine, deep within Jupiter and Saturn, a layer where it literally rains liquid diamond. It's a diamond ocean, collecting deep inside. As this liquid diamond rain falls, it could influence the planet's powerful magnetic field. The patterns we see on Jupiter and Saturn are just the outermost expression of this incredible hidden world. See a world where diamonds fall, only to melt into seas of liquid treasure. This is the reality of our solar system, far more wondrous than we ever dared to imagine. Let us turn inward to visit Venus, a world that should have been our twin. It is nearly the same size as Earth, with a similar mass and density. For centuries, astronomers imagined it as a lush, tropical paradise. But Venus is not our sister. It is a vision of hell. The surface of Venus is the hottest in our solar system. What went so horribly wrong? The answer lies in its atmosphere, composed almost entirely of carbon dioxide. The planet is a victim of a runaway greenhouse effect, boiling away its oceans. This is a profound cautionary tale and a stark demonstration of how a planet's climate can be pushed past a point of no return, reminding us of the fine line between a garden and a furnace. Let's rewind the cosmic clock, back 4 billion years. In its youth, Venus may have been a very different world. Evidence suggests it could have been much more like Earth, a cooler planet with vast oceans of liquid water on its surface. The young sun was fainter then, providing less heat. Under these conditions, Venus could have been habitable, perhaps for billions of years. It's tantalizing to imagine a serene blue Venus, a true sister world where the chemistry of life might have begun to stir in its warm, shallow seas. But a slow, inexorable process was underway, a chain reaction that would seal the planet's fate. As the sun aged, it grew brighter and hotter, just as our star continues to do today. More solar energy reached Venus, and its surface temperature began to creep upward. This increased heat caused more water from its oceans to evaporate into the atmosphere. Water vapor, as it turns out, is itself a potent greenhouse gas. So, as more water vapor entered the atmosphere, it trapped more heat, which in turn caused the surface to get even warmer, which then caused even more water to evaporate. This is the beginning of the runaway feedback loop, a vicious cycle that, once started, is nearly impossible to stop. The cycle accelerated. A point was reached where the oceans literally began to boil away into the atmosphere. The entire planet was enveloped in a thick, dense atmosphere of steam. High up in this steamy blanket, the intense ultraviolet radiation from the sun worked its own destructive magic. The UV rays were powerful enough to split the water molecules apart, breaking them down into their constituent hydrogen and oxygen atoms. This process, called photodissociation, was happening on a planetary scale, systematically destroying the world's supply of water. The hydrogen, being the lightest of all elements, was a cosmic escape artist. Once freed from the water molecule, the hydrogen atoms were not held tightly by Venus's gravity, and they bled away into space, lost to the planet forever. The heavier oxygen atoms remained, and likely combined with carbon from the planet's crust, spewed out by widespread volcanic activity to form the immense quantities of carbon dioxide we see today. The planet's water was permanently lost, and its atmosphere was forever changed, leaving behind the dense, dry, carbon dioxide-choked inferno that remains as a monument to this climate catastrophe. The runaway greenhouse effect left behind an alien world. The sky on Venus is a murky, oppressive orange-yellow, filtered through thick clouds of sulfuric acid. It rains concentrated sulfuric acid, evaporating before it reaches the intensely hot surface. The dense atmosphere creates bizarre effects, eroding rocks. Standing on the surface would feel like being at the bottom of a murky sea of gas. There is no relief from the heat. The entire planet is locked in a permanent, inescapable heat wave. High in the atmosphere, there exists a layer where conditions are surprisingly Earth-like. The pressure and temperature are comfortable. Could microbial life have retreated to this atmospheric haven? Venus stands as a stark reminder of planetary fragility. It is a warning that the delicate balance that sustains our world is a precious gift. Come with me to Mars, a world that whispers tales of a long-lost past. Today it appears as a cold, desiccated desert, but hidden within this barren landscape are clues of a dramatically different epoch. A time when this world was not red but blue, a time when liquid water flowed freely across its surface, vast enough to rival the oceans of Earth. Robotic explorers have tirelessly worked to uncover Mars' secrets. They analyze ancient river deltas and drill into sedimentary rock formations. The story they are uncovering is one of profound transformation. Imagine standing on the shores of this ancient Martian sea, billions of years ago. We see the dendritic patterns of ancient river valleys, unmistakable signatures of flowing water. These are the fossils of an ocean, the ghostly fingerprints left behind by a world that once held the promise of liquid water. So, where did all the water go? To lose an entire ocean requires a cataclysm, a cosmic heist. The prime suspect is the planet's own core. On Earth, our molten iron core generates a magnetic field, a global shield. This magnetosphere deflects the solar wind, protecting our atmosphere and oceans. Mars, however, was not so fortunate. Early in its history, Mars likely had a similar protective magnetic field. Over time, its core cooled and solidified. The dynamo sputtered and died, and Mars became vulnerable. This solar onslaught was a slow process of planetary erosion. The atmosphere thinned, the pressure dropped, and the planet grew colder. What we see today is the aftermath, a world stripped bare. The story of Mars's lost ocean forces us to ask, if conditions were once right for life, did it ever begin? The possibility is what drives our exploration of this rusty world. If life arose on Mars, surviving organisms would have retreated underground. Geothermal heat could melt subsurface ice, creating habitable aquifers. Our rovers are drilling into the rock looking for biosignatures. Finding such a signature in an ancient lakebed would be one of the most significant discoveries in human history. It represents the possibility of a second Genesis, telling us which aspects of our biology are universal. These are the questions that hang in the balance. The ancient, dried-up ocean of Mars holds the potential to redefine our understanding of life itself. Let us venture to the undisputed king of the solar system, Jupiter. This gas giant has no solid surface, only a bottomless atmosphere. Its most iconic feature is the Great Red Spot, a storm that dwarfs any on Earth. This persistent vortex has been raging for centuries, wider than our entire planet. Unlike Earth's hurricanes, Jupiter's Great Red Spot draws energy from the planet's internal heat. It's a testament to the sheer power of the cosmos, a storm for the ages. The Great Red Spot's energy is connected to Jupiter's dizzying speed of rotation. While Earth has a leisurely 24-hour day, Jupiter completes a spin in just under 10 hours. This is the shortest day in our solar system. Imagine a world 11 times the diameter of Earth, spinning more than twice as fast. This rapid rotation causes the gas giant to bulge at its equator and flatten at its poles, making it an oblate spheroid. As the gas cloud that became Jupiter collapsed, it began to spin faster. This rotational energy drives its atmospheric dynamics, organizing weather into colorful bands. The sun would rise and set in less than 5 hours. This creates the most powerful magnetosphere of any planet, nearly 20,000 times stronger than Earth's. Jupiter's short day drives its weather, shape, and magnetic shield. It is the frantic pulse of a giant. Jupiter has a day that lasts less than 10 hours, and a storm that has lasted for centuries. But what exactly is a day on a planet with no solid surface? On Earth, a day is measured by its solid crust, but on Jupiter, there is no such point. Different parts of its atmosphere rotate at different speeds, called differential rotation. Astronomers define a day based on the rotation of Jupiter's magnetosphere, tied to its deep interior. So Jupiter's missing day is really a day that's missing a solid anchor. Deep inside, liquid hydrogen becomes a metallic fluid. At the center, a fuzzy core of rock, ice, and hydrogen. Jupiter redefines what a planet can be. From the largest planet in our solar system, we now journey to the smallest. Let's travel inward, past the orbits of Earth and Venus, to the sun-scorched innermost world, Mercury. This is a planet of extremes, a world of fire and ice. By day, its surface temperature soars to over 400 degrees Celsius, hot enough to melt lead. By night, with no atmosphere to trap the heat, it plummets to a frigid minus 180 degrees. For a long time, we thought of Mercury as a geologically dead world, a static, cratered ball of rock, much like our moon, its story written long ago and finished. But we were wrong. Our modern view of Mercury has been shaped by two heroic robotic missions, Mariner 10 in the 1970s and more recently the Messenger spacecraft, which orbited the planet for 4 years. Messenger's detailed mapping of the entire surface revealed something astonishing, something that hints at a dynamic, evolving world. Crisscrossing the planet are enormous cliffs and scarps, some stretching for hundreds of kilometers and rising over a kilometer high. These are not the result of ancient volcanism or tectonic plates like we see on Earth. They are something else entirely. They are wrinkles. These features, formerly known as lobate scarps, are essentially massive planetary-scale wrinkles in Mercury's crust. They are thrust faults, formed when one section of the crust is pushed up and over another. Imagine an apple left out for weeks, slowly losing its moisture and shrinking. As it shrinks, its skin begins to wrinkle and fold. Mercury is doing the exact same thing on a planetary scale. The entire planet is contracting, and these giant scarps are the evidence. Mercury is, quite literally, a shrinking world. This discovery fundamentally changed our perception of the planet. It is not a dead, static relic. It is a world that is still geologically active, albeit in a very different way from Earth. The forces shaping its surface are not driven by the churning of a mantle, but by a global process of cooling and contraction. These wrinkles tell a story of a planet losing its primordial heat to the cold vacuum of space, a process that has been ongoing for billions of years and continues to this day. Mercury is not just a historical artifact. It is a world in motion, slowly crumpling under its own weight. What is driving this planetary shrinkage? The answer lies deep within the planet, in its enormous, oversized heart. Mercury is the densest planet in the solar system after Earth, and for a good reason. It possesses a metallic core that is absolutely colossal relative to its size. While Earth's core makes up about 16% of its volume, Mercury's iron core is estimated to occupy a staggering 60% of its volume, making it more like a giant ball of metal with a thin, rocky coating. This disproportionately large core dominates the planet's character and its evolution. The origin of this giant core is a subject of intense scientific debate. One leading hypothesis suggests that in the violent early days of the solar system, a much larger proto-Mercury was struck by a massive planetesimal. This giant impact would have been catastrophic, blasting away much of the planet's original rocky mantle and crust, leaving behind the dense, iron-rich core we see today. Another idea posits that Mercury formed very close to the young, hot sun, where the solar wind was so intense it simply vaporized and blew away the lighter silicate rocks from its surface, concentrating the heavier metals. Regardless of how it formed, this massive iron core is the engine of Mercury's contraction. Like any hot object, the core has been steadily cooling over the 4.5 billion years since its formation, radiating its heat out into space. As the molten iron cools, it solidifies. And just as water contracts when it freezes into ice, molten metal contracts and becomes denser as it solidifies. This slow, ongoing process of the liquid outer core freezing onto the solid inner core causes the entire planet to shrink in volume. The planet's crust, already solid and brittle, has nowhere to go. So it buckles. The immense compressive stress builds up in the crust until it fractures, thrusting one part over another, creating the lobate scarps we see on the surface. Messenger's observations suggest that the planet's radius has shrunk by as much as 7 kilometers over its lifetime. This is not just an ancient process. Some of the scarps appear remarkably fresh, cutting across younger craters, suggesting that Mercury is still actively contracting today. The wrinkled face of Mercury is a direct, visible consequence of the cooling of its giant iron heart, a slow-motion geological event playing out across an entire world. The idea of a shrinking planet is a profound one. It suggests that planetary evolution is not a story that is finished and done. The worlds of our solar system are not static museum pieces. They are dynamic, active bodies, each with its own ongoing story. Mercury's story is one of thermal contraction, a quiet, relentless process that continues to reshape its surface. The ground beneath a hypothetical future visitor's feet would be, in a very real sense, unstable. The planet is still settling, still adjusting to its own cooling. The formation of a new scarp would be a merkquake, a seismic event of planetary scale. This ongoing activity has fascinating implications. It paints a picture of a world caught between fire and ice, between its hot past and its cold future. The cooling core is not just causing wrinkles. It also helps to generate Mercury's weak but complex magnetic field. Unlike Earth's field, which is generated by a vigorously churning outer core, Mercury's field is thought to be generated by a more subtle sloshing in a thin shell of its remaining liquid core. The fact that it has a magnetic field at all is a surprise, and another clue that its interior is not entirely frozen. The study of Mercury's contraction provides a unique window into the thermal history of terrestrial planets. By studying the size, distribution, and age of these wrinkles, scientists can model how quickly the planet has cooled over time. This helps us understand not just Mercury, but the fundamental processes that govern the evolution of all rocky worlds, including our own. Earth also loses heat from its core, but its geology is dominated by plate tectonics, a process that recycles the crust and relieves stress in a different way. Mercury, being a one-plate planet, has no such outlet, so the stress manifests as these dramatic global wrinkles. So, the next time you look at an image of Mercury, don't just see a cratered, desolate rock. See a planet that is alive with the slow, powerful forces of planetary cooling. See the wrinkles not as scars of an ancient past, but as fresh evidence of a world still in the process of becoming. It's a subtle, quiet form of geologic activity, but it is activity nonetheless. The smallest planet is telling us a grand story about the life and death of planetary heat, a story written in the crumpled, shrinking skin of a world with a giant iron heart. Out there in the cold, distant suburbs of our solar system drifts Uranus, a pale, blue-green orb, harboring a profound and ancient secret. It appears to have been knocked over, toppled from its throne. Its orientation in space is a profound anomaly. It doesn't spin like a top, instead it rolls like a ball. It lies on its side, its axis tilted at a staggering 98 degrees. This extreme tilt means that for long stretches of its 84-year orbit, one pole faces the sun directly. It's a world of extreme seasonal swings. What could have happened to this ice giant to leave it in such a peculiar state? A cosmic collision of unimaginable force. It's a silent, frozen testament to the brutal billiards game that played out in the early years of our solar system. To understand the plight of Uranus, we must rewind the cosmic clock. Back some 4 billion years, the solar system was a much younger, more turbulent place. A chaotic shooting gallery of planetesimals, protoplanets, and leftover debris from the sun's formation. It was in this primordial chaos that the planets we know today were forged. They grew by accretion, sweeping up smaller bodies in their gravitational embrace. But this process was not always gentle. Sometimes the encounters were not mergers, but devastating, planet-altering collisions. This is where the leading hypothesis for Uranus's condition takes center stage. The theory posits that a massive object, perhaps an Earth-sized protoplanet, careened through the young solar system and delivered a cataclysmic, glancing blow to the nascent Uranus. This wasn't a head-on impact, which might have shattered the planet entirely. Instead, it was an oblique strike, a cosmic haymaker that transferred an immense amount of rotational energy. The force of this impact was so profound, so utterly titanic, that it literally knocked the entire planet over, torquing its axis of rotation until it lay nearly parallel with its orbit. The fallen giant was born from a single, universe-shaking moment of violence. Computer simulations that model this ancient impact show how such an event could not only explain the 98-degree tilt, but also other Uranian mysteries. For instance, the collision could have churned the planet's interior, mixing its core materials of rock and ice with its upper layers of hydrogen, helium, and methane. This might explain why Uranus, unlike its gas giant cousins, radiates so little internal heat into space. Its primordial heat may have been catastrophically expelled during the impact. The event didn't just change its orientation, it fundamentally reshaped its internal structure and its thermal destiny. The debris from this colossal smash-up wouldn't have just disappeared. It would have been thrown into orbit around the wounded giant. Over time, this cloud of shattered rock and ice could have coalesced to form the system of moons and faint dark rings that we see around Uranus today. This means that Uranus's entire satellite system might be the children of that ancient cataclysm, born from the very event that so profoundly altered their parent. The planet, its tilt, its moons, and its rings, all may be interconnected pieces of a single violent story, written in the language of gravity and collision. The consequences of this epic tilt are not just a historical footnote. They are an ongoing reality that shapes every aspect of the Uranian environment. Let's journey to one of its poles during its long, 21-year summer. For 2 decades, the sun never sets. It simply circles high in the sky, bathing that hemisphere in constant, unrelenting sunlight, albeit weak sunlight. There is no day or night, only a perpetual twilight caused by the sun's immense distance. An observer standing there would experience a day that lasts for a quarter of their lifetime, a season of endless light before the long, dark winter inevitably arrives. Meanwhile, on the other side of the planet, the opposite pole is experiencing a winter of equal, terrifying length. 21 years of absolute darkness and unimaginable cold, a polar night from which there is no escape. The temperature plunges to depths we can scarcely imagine, a profound cryo-sleep. And the equatorial regions? They experience a bizarre, rapid cycle of day and night as the planet rolls along its orbit. During the equinoxes, when the sun is directly over the equator, the planet spins normally relative to the light, giving it a day-night cycle of just over 17 hours. It's a world with 2 completely different climate regimes. You might expect the sunlit pole to be significantly warmer than the dark one, but observations have revealed another Uranian puzzle. The temperatures across the entire planet are surprisingly uniform. The dark pole is nearly as warm as the one basking in decades of sunlight. This suggests a powerful atmospheric dynamic at play, a global weather system of immense scale that redistributes the sun's energy from the light side to the dark side. Massive planet-spanning storms and supersonic winds must be raging in its blue-green atmosphere, acting as a planetary heat exchange system to balance the extreme solar inputs. This creates weather patterns unlike anything seen elsewhere. During the long polar summers, colossal storm systems, some the size of continents on Earth, can form and rage for years. Then, as the planet approaches its equinox, the changing solar energy can trigger even more violent weather across the entire globe. The extreme tilt of Uranus doesn't just give it long seasons, it creates a meteorological laboratory for the most extreme and bizarre atmospheric phenomena in the solar system. It's a world perpetually off balance, its climate forever trying to catch up with its own lopsided reality, a beautiful, chaotic consequence of an ancient cosmic wound. Come with me to the edge of our solar system, to Pluto, king of the Kuiper Belt. This realm of profound cold and deep mystery was once thought of as a simple inert ball of ice and rock. But in 2015, NASA's New Horizons spacecraft revealed a vibrant, geologically active landscape. Among these alien features, evidence of volcanoes that erupt with ice, slush, and frozen gases. This concept, cryovolcanism, challenges our very definition of what a volcano can be. Scientists theorize pockets of a subsurface ocean kept liquid erupt when it finds a weak point in the crust. It doesn't erupt with fire, it erupts with cold. This is not the geology of Earth, but a testament to the fact that even in the coldest corners of our solar system, the universe finds a way to be dynamic. Let's zoom in on Right Mons. It's immense, about 150 kilometers across and 4 kilometers high. Its most telling feature is the vast, deep caldera at its summit. This structure shouts volcano. Scientists estimate Right Mons is composed of thousands of cubic kilometers of cryolava, suggesting sustained geological activity. It implies a long-lived internal heat source. The leading hypothesis points to a subsurface ocean, kept liquid by ammonia and internal heat. This hints at habitability in the universe. The real action might be happening deep inside, in hidden oceans warmed by internal heat. The number of potentially habitable worlds may be vastly greater than we ever dared to imagine. Pluto isn't alone in its icy eruptions. Cryovolcanism is a recurring theme in the outer solar system, seen on Neptune's moon Triton and Saturn's moon Enceladus, where plumes of water vapor erupt from its south pole. Cassini found water, salt, and complex organic molecules, hinting at a subsurface ocean. Jupiter's moon Europa also shows cryovolcanic activity. These active worlds suggest that life might thrive in subsurface oceans, powered by chemical energy, reminding us that the next great discovery could be waiting in the most unexpected of places. We orbit a star, our sun. It's the source of our energy, the anchor of our world, the giver of life. Its light and warmth travel 93 million miles through the vacuum of space to nurture our planet, driving our climate, powering photosynthesis, and making our existence possible. We bask in its gentle rays. We chart our years by its journey across the sky. It feels so constant, so reliable, so benevolent, a steady, unwavering presence in our lives. But this perception of a calm, peaceful star is a dangerous illusion, born from the cosmic luck of living in a relatively quiet period of its long and often violent life. The sun is a star, and stars are not peaceful. It is a gigantic, churning ball of superheated plasma, a continuous nuclear furnace converting hydrogen into helium in its core. This process unleashes an amount of energy that honestly dwarfs anything humanity has ever conceived. And this energy is not released in a perfectly smooth, uniform way. The sun's surface is a roiling, chaotic place, governed by unimaginably powerful magnetic fields. These fields, generated by the flow of electrically charged plasma deep within the sun, get twisted, tangled, and stressed, like immense cosmic rubber bands. When these tangled magnetic field lines suddenly and violently reconfigure themselves, they release a colossal amount of energy in an event we call a solar flare. A single large flare can unleash the energy of billions of hydrogen bombs, all detonated in the space of a few minutes. This explosion accelerates charged particles, protons and electrons, to nearly the speed of light and floods the solar system with a blinding flash of radiation, from radio waves to X-rays and gamma rays. It is one of the most powerful explosive events in our solar system, a reminder of the untamed power simmering just next door. For most of Earth's history, these tantrums were of little consequence to life, which was safely shielded by our planet's atmosphere and magnetic field. The most dramatic effect might have been a particularly spectacular aurora, but we no longer live in that world. We have built a new global ecosystem, a civilization built on a delicate scaffolding of technology. Our power grids, our satellites, our communication networks, our GPS systems, all of it is vulnerable. We have, in effect, wrapped our planet in a sensitive electronic nervous system, and that system is directly in the line of fire of our star's awesome and unpredictable fury. To understand the threat, we don't need to look to science fiction. We only need to look back in our own history, to a time before the digital age, before the world was wired. The year was 1859. On the morning of September 1st, a British astronomer named Richard Carrington was in his private observatory, sketching sunspots. Suddenly, he witnessed something no one had ever seen before: a white light flare, an intensely brilliant flash of light erupting from the group of sunspots he was observing. He had just become the first human to witness a major solar flare, an event that would soon bear his name. What Carrington saw was just the beginning. The flare was accompanied by something even more dangerous: a coronal mass ejection, or CME. This is a massive bubble of magnetized plasma, billions of tons of the sun's own atmosphere, hurled out into space at millions of miles per hour. This particular CME was aimed directly at Earth. It took just 17.6 hours to cross the 93 million mile gap, a journey that normally takes 3 to 4 days. It was one of the most powerful and fastest moving solar storms ever recorded. When it hit, the consequences were immediate and dramatic. Earth's magnetic field, our planetary shield, was overwhelmed. The CME slammed into it, compressing it and inducing massive electrical currents in the ground below. The nascent global telegraph system, the technological marvel of its day, went haywire. Sparks flew from telegraph machines, operators received electric shocks, and papers were set on fire by the surges. Some systems were so supercharged by the storm that operators could disconnect the batteries and continue sending messages using only the auroral currents induced by the storm. It was a shocking demonstration of the sun's power. The most beautiful effect was also the most ominous. The aurora borealis and aurora australis, normally confined to the polar regions, were seen all over the world. People in Cuba, Hawaii, and Rome saw the night sky light up in brilliant shades of red, green, and purple. The light was so bright that people in the Rocky Mountains woke up and started preparing breakfast, thinking it was dawn. It was a beautiful spectacle, but it was the sign of a planetary-scale electromagnetic disturbance. If the Carrington event happened today, it wouldn't just disrupt a few telegraph lines. It would be a catastrophe on a global scale. Imagine the Carrington event in the 21st century. The initial blast of X-rays from the flare would saturate satellites, potentially causing permanent damage and knocking out communications and GPS. Then, hours later, the coronal mass ejection would arrive. Its impact on our magnetosphere would induce powerful geomagnetically induced currents in our power grids. Transformers, the backbone of our electrical distribution system, would overheat and melt. Not just a few, but potentially hundreds of them across entire continents, plunging vast regions into a blackout that could last not for days or weeks, but for months, or even years. Without electricity, our modern world grinds to a halt. No clean water being pumped to our homes, no refrigeration for food or medicine, no functioning hospitals, no financial systems as ATMs and credit card networks go dark, no fuel being pumped at gas stations, no internet, no television, no radio, no phones. It would be a cascading failure of all the interconnected systems that support our society. A 2013 report from Lloyd's of London estimated that the cost of such an event to the United States economy alone could be as high as $2.6 trillion, with a recovery time of 4 to 10 years. You might think this is a remote possibility, a once-in-a-millennium event, but you would be wrong. On July 23, 2012, a solar storm of Carrington-class intensity erupted from the sun. An immense CME tore through Earth's orbit. But we got lucky. By sheer cosmic chance, The Earth had been in that exact spot just 1 week earlier. We missed a direct hit by about 9 days of orbital travel. We dodged a bullet of celestial proportions. A 2014 study calculated that the probability of a Carrington-level storm hitting Earth in the next decade is about 12%. This is not a question of if, but when. We are, in a very real sense, children of the sun. We depend on it for our very lives. But we are also at its mercy. We live on the knife edge of its temperament, thriving in its calm, but utterly vulnerable to its rage. Our star, the bringer of life, also holds the power to send our technological civilization back to the 19th century in a matter of hours. This profound dependency and vulnerability is one of the most shocking and humbling truths of our existence in this solar system. It compels us to understand, to prepare, and to remember our place in the cosmos. We've journeyed across billions of miles and years, from gas giants to the Kuiper Belt. We've seen carbon, the very stuff of life, falls like diamonds on Jupiter and Saturn. We've felt the heat of Venus, walked the dry riverbeds of Mars, and stood in awe of Jupiter's great red spot. We've uncovered the cryovolcanoes of Pluto, and we've looked back at our own sun. Our solar system is dynamic and filled with wonders. The story of the cosmos is the story of us. Every discovery teaches us something new about our own planet. All we have to do is listen. The quest for knowledge is the most noble adventure of our species. The journey has just begun. Imagine the universe as a vast, dark ocean. Light journeys for billions of years, moving at an incredible speed. This is the speed of light, once thought to be the absolute cosmic speed limit. It dictates the pace of information, woven into the very fabric of space and time. This universal speed limit keeps the universe orderly. But what if something didn't have to play by the same rules? This brings us to gravity, the force that holds everything together. Could gravity break the ultimate speed limit? Does gravity travel faster than light? The answer could shatter our picture of reality. The journey to find the answer is a story of human curiosity. Let's explore this mystery with a simple thought experiment. Picture the sun. Its immense gravity keeps Earth in orbit. Imagine a cosmic magician suddenly makes the sun disappear. What would happen on Earth? It would take about 8 minutes for darkness to fall. But what about gravity? Would Earth continue its orbit, or fly off into space the instant the sun vanished? If gravity acts instantaneously, Earth would be immediately released. This would mean gravity travels faster than light, challenging our understanding of cause and effect. Einstein described gravity as a curvature of space and time. Think of space as a rubber sheet. A heavy object like the sun warps it. If the sun vanished, it would create a ripple. How fast does this ripple travel? The speed of gravity has real, practical consequences for how we explore the universe. Our most advanced technologies, like telescopes and space probes, rely on a precise understanding of gravity. A precise number is essential for navigating our cosmic neighborhood. Furthermore, our quest to understand the universe's most dramatic events depends on knowing gravity's speed. If we can detect gravitational waves here on Earth, they give us a completely new way to see the universe. This question also connects directly to some of the biggest unsolved mysteries in science. The speed of gravity is a critical piece of this puzzle. It helps us test our theories and guides us toward a deeper understanding of how the universe works. Ultimately, the desire to know the speed of gravity is driven by the same human curiosity. Learning the answer tells us something profound about the nature of reality. To understand gravity, we travel back to the 17th century. Here we meet Isaac Newton. The story is that he was sitting under an apple tree one day. He watched an apple fall. This sparked a revolutionary thought. He wondered if the same force pulled the apple to Earth and held the moon in orbit. The universe was governed by a single universal law of gravitation. The force pulling the apple was the same force holding planets in their orbits. Every object in the universe attracts every other object. The strength depends on mass and distance. Newton could explain why apples fall down. He could also predict the orbits of the planets. Newton's gravity was a force that acted across space. Newton's theory painted the universe as a grand, interconnected machine. Imagine invisible strings stretching between every object. The sun pulls on the Earth, and the Earth pulls on the moon. According to Newton, this pull was felt everywhere, all at once. If the sun's mass changed, the Earth would feel it instantly. This idea of action at a distance was unsettling, even to Newton. His law predicted motion, but offered no mechanism for how the pull was transmitted. Astronomers used Newton's laws to discover Neptune, confirming his theory. But the concept of instant gravity conflicted with the discovery that light has a finite speed. How could gravity be instant if nothing else was? Something had to give. For centuries after Newton, the universe was seen as a giant, predictable clockwork. His laws of motion and gravity made the cosmos seem rational and understandable. Space and time were thought to be absolute, unchanging backdrops for all events. This view powered the Industrial Revolution and scientific progress. But not everything fit. Mercury's orbit, for example, showed a tiny, unexplained wobble. Astronomers searched for a hidden planet, Vulcan, but found nothing. The real problem was deeper. Newton's laws, though powerful, were incomplete. The universe wasn't a perfect machine after all. It was stranger and more wonderful than Newton ever imagined. The cracks in the clockwork were about to widen. By the late 1800s, Newtonian physics faced serious challenges. Mercury's orbit was one. The nature of light was another. Maxwell's equations showed light always travels at the same speed, no matter how you move. This clashed with Newton's ideas of absolute space and time. Physics was at a crossroads, two successful theories, but fundamentally incompatible. Enter Albert Einstein, a young outsider obsessed with these contradictions. He saw that the minor puzzles were clues to a deeper reality. The universe needed a new framework. The stage was set for a revolution. Everything was about to change. Einstein's special relativity shattered the old ideas of absolute space and time. Space and time became relative, woven into a single fabric space-time. Gravity, he realized, wasn't a force but the warping of space-time by mass and energy. Planets followed the curves in this fabric, not invisible strings. His general relativity replaced Newton's action at a distance with elegant geometry. Mercury's orbit finally made sense. The universe was now a dynamic, flexible tapestry. But a new question emerged. How fast do changes in gravity travel? If gravity is a ripple in space-time, does it have a speed limit? The answer would reshape our understanding of the cosmos. Imagine space-time as a trampoline. The sun is a heavy ball, curving the surface. Earth is a marble, following the curve. Gravity is not a force, but motion along these curves. If the sun vanished, the change would ripple outward, not instantly, but at a finite speed. Einstein's equations showed these ripples move at the speed of light. Gravity, like light, has a cosmic speed limit. If the sun disappeared, Earth would feel it 8 minutes later. The same time sunlight fades, the universe's logic and order are preserved. Every orbit, every falling apple, is a dance on the shifting sea of space-time. The cosmos is alive, not static. Einstein's math predicted space-time could vibrate. Gravitational waves. Colliding black holes or neutron stars would send ripples across the universe. For decades, these waves were only theory, too faint to detect. But if found, they'd reveal the true speed of gravity. In 2015, LIGO detected gravitational waves from merging black holes. The waves arrived at the speed of light, matching Einstein's predictions. Gravity is not instantaneous. It obeys the same speed limit as light. This discovery was a triumph for Einstein's vision. The universe's deepest rhythms were finally heard. Gravity plays by the same rules as everything else. The old idea of instant gravity is gone. Changes in gravity travel at light speed, preserving cause and effect. When we look at the stars, we see them as they were, not as they are. If a star explodes, its last light and last gravitational tug reach us together. Every cosmic event is synchronized by nature's speed limit. Einstein's revolution changed how we see time, space, and our place in the universe. Yet mysteries remain. Physicists keep searching for cracks in the code. For now, gravity does not outpace light. The universe is woven by this ultimate law. Our journey to this truth shows the power of imagination and discovery. Imagine the sun suddenly vanishes. In Newton's universe, Earth would feel the loss of gravity instantly before the sunlight faded. For 8 minutes, we'd see the sun shining, even as we were flung into darkness. Gravity's effect would arrive before its cause, breaking the rules of nature. This paradox troubled physicists deeply. It showed that Newton's theory was incomplete. Information can't travel faster than light. Einstein's ideas resolved the contradiction. The universe needed a new theory, one that respected the cosmic speed limit. The conundrum led to a revolution in our understanding of reality. Einstein's theory of special relativity was built on the principle that the speed of light is the ultimate cosmic speed limit. To solve the paradox of gravity acting instantly, Einstein reimagined gravity not as a force, but as a consequence of the geometry of space-time. Massive objects like the Sun create a curve in this fabric. The Earth is simply following the straightest possible path through this curved space-time. This changes the nature of the problem. If the Sun disappears, it is a matter of the dent in the space-time fabric smoothing out. This smoothing out process cannot happen everywhere at once. Einstein's equations predicted that this gravitational ripple would travel outward at the speed of light. For 8 minutes and 20 seconds, nothing would change on Earth. Then the Earth would be released from its orbit. The universe remains a rational, predictable place. Let's dig deeper into the strangeness of infinitely fast gravity. Consider two planets, Planet A and Planet B, orbiting a distant star. Now, picture the star suddenly exploding. According to instantaneous gravity, both planets would feel the gravitational shock wave at the exact same moment, instantly disrupting their orbits. An astronomer on Planet B would detect that their world had been thrown from its orbit for no apparent reason, a paradox. This violates causality, the idea that a cause must happen before its effect. This highlights why the speed of gravity is so critically important. An infinite speed would allow for information to be transmitted backwards in time, leading to nonsensical outcomes. Einstein's insistence that gravity travels at the speed of light was necessary to save reality from its own contradictions. We have explored the problems with an infinitely fast gravity. But what if gravity were much slower than light? Let's imagine a different kind of universe, one where space-time ripples travel at half the speed of light, or even at the speed of a car. The consequences for the stability of our solar system would be catastrophic. Consider the Earth's orbit around the Sun. The Earth is constantly being pulled toward the Sun's current position. But if gravity were significantly slower, the Earth would be pulled toward where the Sun was minutes or hours ago. This time, lag would introduce a fatal instability into our orbit, creating a small but relentless sideways force. This continuous forward tug would act like a cosmic accelerator, injecting energy into our orbit. The Earth would begin to spiral outwards. A universe with a slow gravity would be a place where stable orbits could not exist. The cosmos would be an unstable, chaotic place. Through these thought experiments, we arrive at a remarkable conclusion. The speed of gravity seems perfectly tuned for a stable universe. It cannot be infinite because that would violate causality. The speed of gravity cannot be significantly slower than light. This lag would introduce a destabilizing force into all orbits. This leaves us with one perfect value, the speed of light. This is the Goldilocks speed, just right. This preserves causality and ensures the universe operates logically. It is the speed of reality itself. All point to the same answer. The speed of gravity must be the speed of light. But what does the real-world evidence say? Physics is sometimes a waiting game. For decades, the predictions of general relativity needed proof, a way to truly measure how fast gravity's ripples move across space. Scientists dreamed of detecting gravitational waves, the actual vibrations in space-time caused by massive cosmic events. But the challenge was daunting. These waves are incredibly faint, stretching and squeezing the very fabric of space-time by less than the width of an atom. How could anyone hope to catch such a tiny fleeting signal amid the constant rumble of earthly noise? The answer lay in ambition, patience, and astonishing technology. In the late 20th century, researchers began building the world's most sensitive listening devices. These were not telescopes, but giant laser interferometers, machines designed to measure the smallest movements ever attempted. The most famous of these is LIGO, the Laser Interferometer Gravitational Wave Observatory, with its twin sites in Louisiana and Washington State. Each L-shaped arm stretches for 4 kilometers, using powerful lasers, ultra-stable mirrors, and a vacuum as pure as outer space to hunt for the faintest tremors in space-time. The goal was simple, but profound: to hear the universe as well as see it. If gravitational waves exist, then somewhere out there, a pair of colliding black holes or neutron stars could send a shudder racing across the cosmos. If LIGO could capture that shudder, it would not only prove Einstein right, it would tell us precisely how fast gravity's influence can travel. For years, LIGO's detectors sat mostly silent, waiting for the cosmic show to begin. The task was immense, a bit like listening for a whisper during a hurricane. Success would require dogged perseverance, countless upgrades, and the collaboration of thousands of scientists. But as the instruments grew ever more sensitive, hope mounted in the halls and control rooms. Was the universe about to reveal one of its deepest secrets? Could humans at last measure the speed of gravity itself? Not through thought experiments, but through the echoes of real cataclysmic events. The breakthrough came on September 14, 2015. Deep in the data stream from the LIGO detectors, scientists spotted a peculiar chirp, a brief rising tone lasting just a fraction of a second. It was tiny, but unmistakable. After years of searching, humanity had finally caught a gravitational wave in the act. The signal had traveled 1.3 billion light-years to reach us, set off by the merger of two colossal black holes spiraling together and coalescing into one. The careful analysis that followed was a triumph of science and engineering. The pattern and timing of the wave matched Einstein's predictions with astonishing precision. The two detectors, separated by thousands of kilometers, both recorded the signal at almost precisely the same moment, allowing scientists to triangulate the direction and, crucially, to estimate the speed at which the wave had traveled. The results were stunning. The gravitational wave had propagated at the speed of light, with no measurable delay. This was the first direct evidence that gravity's message races across the universe no faster and no slower than light itself. This discovery marked the birth of gravitational wave astronomy, a whole new way to explore the universe. No longer were astronomers limited to what they could see with light. Now they could listen to the universe's deepest rumblings. Each detection offered a new test of general relativity, a new opportunity to measure fundamental properties like the speed of gravity. LIGO's success was celebrated around the world, earning the 2017 Nobel Prize in Physics for the project's founders. But the story did not end with one chirp. Since 2015, LIGO and its European counterpart Virgo have detected dozens more gravitational wave events, each one providing fresh confirmation. Again and again, the results align. Gravity's ripples travel at the cosmic speed limit set by light. The era of speculation and paradox was over. The speed of gravity was no longer just a matter of theory, it was now a matter of observation. The ultimate test came in 2017 with an event that electrified the world of astronomy. That August, LIGO and Virgo detected a new and different kind of signal, a gravitational wave from two merging neutron stars, not black holes. Unlike black holes, neutron star collisions produce not only gravitational waves, but also a brilliant burst of electromagnetic radiation, gamma rays, visible light, and more. For the first time, scientists could compare the arrival times of both messages, the gravitational wave and the flash of light. As the signal swept across the Earth, observatories around the globe and in space turned their eyes to the spot in the sky identified by LIGO and Virgo. Just 1.7 seconds after the gravitational wave passed through, NASA's Fermi Gamma Ray Space Telescope detected the gamma ray burst from the same event. When the data were analyzed, the difference in arrival times, over a journey of 130 million light-years, was astonishingly small. The gravitational wave and the light had traveled at almost exactly the same speed, differing by less than one part in a quadrillion. This was a cosmic confirmation. If gravity traveled any faster or slower than light, even by the tiniest amount, the signals would have arrived years, centuries, or even millions of years apart. Instead, they arrived in virtual lockstep. This result put to rest any lingering doubts. The speed of gravity is not just close to the speed of light. It is, for all practical purposes, identical. The 2017 neutron star merger remains one of the most significant astronomical events of the century. It unified the realms of gravity and light, turning theory into fact. It also allowed scientists to rule out many exotic theories that had suggested otherwise. No hidden loopholes, no superluminal shortcuts for gravity. The universe, it seems, keeps its best secrets in plain sight. The era of gravitational wave astronomy has only just begun, but it is already reshaping our understanding of the cosmos. With each new detection, scientists are able to test general relativity in realms of extreme gravity and high energy, places where its predictions could, in principle, break down. LIGO and Virgo continue to refine their techniques, increasing sensitivity and reducing uncertainty, making each new measurement of gravity's speed even more precise. In parallel, astronomers use other tools to probe the universe for signs of anything amiss. They measure the orbits of planets and moons with exquisite precision, searching for the slightest hint of a lag or lead in gravitational interactions. The 2002 observation of Jupiter passing in front of a distant quasar allowed astronomers to measure the effect of Jupiter's gravity on the light from the quasar. Their findings once again matched Einstein's prediction. Gravitational effects propagate at the speed of light, not instantaneously. Even so, the door to new physics is never fully closed. Some researchers continue to explore ideas from quantum gravity and string theory that predict possible deviations, in rare or extreme circumstances, from this universal speed limit. Could gravity's waves be slowed or sped up by unknown particles or extra dimensions? So far, all the evidence aligns with Einstein's vision, but the search for anomalies continues. Each new experiment, each new gravitational wave detected, is another opportunity to challenge the boundaries of known science. These ongoing discoveries are not just academic. They have practical consequences for everything from satellite navigation to our understanding of dark matter and dark energy. If, someday, we find even the tiniest crack in the speed of gravity, it could open a window to new laws of nature and a deeper grasp of the universe's most profound mysteries. We have come a long way from the early days of Newton's invisible strings and Einstein's elegant equations. Thanks to real-world experiments, thought experiments have given way to hard data. Gravitational waves, once only a mathematical prediction, are now a routine part of astronomy, carrying fresh proof of the universe's rules with every ripple that reaches Earth. The question, does gravity travel faster than light, has been answered with a resounding no. Gravity and light are cosmic twins, racing side by side through the great expanse. But this is not the end of the story. Instead, it is a new beginning. The ability to measure the speed of gravity so precisely has opened a new sense for science, a way for humanity to hear the universe as well as see it. Gravitational wave astronomy gives us a backstage pass to the most dramatic events in the cosmos: black hole mergers, neutron-star collisions, the birth and death of stars. It provides clues to questions we never even knew to ask. What happens inside a black hole? How did the universe begin? Are there unknown forces or particles lurking in the dark? The excitement is palpable among physicists, astronomers, and space enthusiasts alike. Each new gravitational wave is not just a confirmation of Einstein's legacy, it is a hint, a whisper, that there is always more to learn. Even as current evidence locks gravity to the speed of light, the search for deeper truths continues. Could quantum mysteries or cosmic anomalies someday redefine our most cherished laws? If history teaches us anything, it is that nature always has surprises in store. So the speed of gravity is more than a number. It is a key to the cosmos, a thread that connects us to every star, every planet, every black hole. Because of it, we are not just observers of the universe. We are participants in its endless unfolding story. From Newton's orchard to the observatories of LIGO, we've discovered gravity has a speed. It matches the speed of light, transforming our understanding of the cosmos. This cosmic speed limit preserves cause and effect, enabling stable orbits and life itself. LIGO's experiments confirm this, marking a triumph of human curiosity. It opens new windows onto the universe, reminding us how much remains unknown. The story of gravity's speed has given us clarity, but it has also left us with a fresh sense of wonder. Space enthusiasts, scientists, and dreamers alike remain captivated by the mysteries that still surround gravity. For all that we know, gravity remains the most enigmatic of nature's forces. Unlike electromagnetism or the strong and weak nuclear forces, gravity's true origins and quantum nature are still hidden in the shadows. The marriage of Einstein's smooth space-time with the jittery world of quantum mechanics is an unsolved puzzle, a theory of everything that continues to elude even our brightest minds. Every new detection of a gravitational wave is a chance to test the limits of our understanding. Could there be subtle differences in the speed of gravity under extreme conditions? Might there be hidden particles, extra dimensions, or new physics waiting to be discovered? As we build more sensitive detectors and peer further into the universe, we may yet stumble upon surprises that force us to rewrite the rulebook once again. The search for quantum gravity, the nature of dark matter and dark energy, and the fate of black holes are all part of this unending quest. This is why the speed of gravity remains an exciting frontier. It is not just a settled fact, but a living question, always open to challenge, revision, and refinement. For space fans and scientists, the thrill lies in the unknown, the possibility that the next ripple, the next cosmic collision, might reveal something astonishing. In this way, the story of gravity's speed is a perfect example of what makes science so powerful and inspiring. The relentless drive to question, to measure, to discover, and to imagine worlds beyond our current reach. So as we look to the skies, we do so with gratitude for the answers we have found, and with anticipation for the mysteries that still await. The speed of gravity connects us to the farthest corners of the cosmos and to the deepest questions of existence. It reminds us that even the simplest questions, like how fast does gravity travel, can lead to revolutions in thought and windows into the infinite. The adventure is not over. If anything, it has only just begun. The night sky looks peaceful, but what if one of those distant stars was heading straight for our solar system? Imagine a rogue star, drifting silently for millions of years, its approach unseen. Its gravity would reach out, threatening the delicate balance that keeps our planets in orbit. This isn't just science fiction, it's a real, if remote, possibility in our dynamic universe. A passing star wouldn't need to collide with anything. Its gravity alone could wreak havoc. Planets could be flung into the sun or out into deep space. Our existence hangs by a thread of gravity and chance, vulnerable to a cosmic intruder. This is the ultimate cosmic threat. Not an asteroid or a supernova, but a gravitational monster. Its effects would start subtly, but as it drew closer, chaos would follow. The ground beneath us, seemingly solid, is part of a system that could be torn apart. The universe is a place of creation and destruction, and we are not immune. So let's imagine, what if a star passed close by? How would it unravel our solar system? We'll explore the science behind this scenario and its implications for Earth and humanity. This is a story about gravity, distance, and the fragile dance of order and chaos. A reminder of our small, vulnerable place in a wondrous but dangerous universe. To grasp the threat, we must first understand what's at stake. Our solar system is a finely tuned system, with planets and countless smaller bodies orbiting the sun. The sun's gravity anchors everything, from Mercury to the distant Oort cloud. This harmony gives us stable seasons and a climate fit for life. Beyond the planets lie the asteroid belt, the Kuiper belt, and the Oort cloud, a vast shell of comets. Every star, including our sun, is in constant motion around the galaxy's center. Our solar system travels through space at incredible speeds, passing through ever-changing neighborhoods of stars. The space between stars is vast, but not infinite. Our system's structure evolved in isolation, but the galaxy is crowded and dynamic. The real question isn't if another star will pass by, but when and how close. The stability of Earth's orbit and the future of life depend on this cosmic choreography. Our peaceful neighborhood could one day face an unwelcome visitor. The solar system's order is fragile and the galaxy's dance never stops. We are always at the mercy of the stars. The good news? Space is unimaginably vast. Our nearest neighbor, Proxima Centauri, is over 4 light-years away, an almost inconceivable distance. This emptiness acts as a shield, making close encounters with other stars extremely rare. Astronomers track nearby stars and predict their paths with precision. Most pass at safe distances. For example, Gliese 710 will come within a light-year in 1.3 million years. Close, but not catastrophic. For a star to truly threaten us, it would need to pass through the inner solar system, a cosmic bullseye. The odds are staggeringly low. Such an event might only happen once in many trillions of years. Still, the universe is old, and improbable events do happen over immense timescales. While we're likely living in a lucky era, the vastness of space is protection, not a guarantee. In the cosmic lottery, rare doesn't mean impossible. Imagine the impossible. A rogue star enters our solar system. At first, it's just a new bright point in the sky, but its gravity arrives first. The Oort cloud's comets would be the first to feel its pull, their orbits twisted and sent hurtling inward. A storm of comets would bombard the inner solar system, lighting up the skies and increasing impacts on planets. The outer giants, Neptune, Uranus, Saturn, Jupiter, would have their orbits disrupted. Jupiter, our shield, could become a slingshot, sending asteroids toward Earth. The solar system's architecture would begin to collapse. As the star passed closer, the inner planets would face disaster. Earth's orbit could become wildly elliptical, causing extreme temperature swings. We could be scorched near the sun, or frozen far away. Or Earth might be captured by the rogue star, or ejected into interstellar space. The solar system's dance would end in chaos. The consequences would be catastrophic. For life on Earth, a stellar flyby would start subtly and end in devastation. The first sign, a comet storm, filling the sky with beautiful but deadly visitors. Impacts would become frequent, triggering firestorms, tsunamis, and plunging the world into darkness. Civilization would collapse, ecosystems would be destroyed. As the rogue star's gravity tugged on Earth, immense tidal forces would stretch the planet's crust. Global volcanic eruptions and massive earthquakes would follow, making the ground itself unstable. If Earth's orbit changed, the climate would swing between boiling heat and deep freeze. Oceans could evaporate, the atmosphere could freeze, and life would be wiped out. Hyper-hurricanes and violent transitions would ravage the planet. The most likely outcomes: Earth ejected into space as a frozen rogue planet, or spiraling into the sun. In any scenario, the story of life on Earth would end. Our planet would become just another piece of cosmic debris. The universe's power is immense and indifferent. Our blue marble's fate would be sealed. Contemplating such a disaster is humbling. We live on a fragile world, balanced by cosmic forces beyond our control. The universe is not gentle. It's filled with wandering stars and immense power. Yet our existence is a testament to the universe's capacity for order. For billions of years, Earth has enjoyed stability, allowing life to flourish. We are living in a rare moment of cosmic calm. Studying these risks isn't about predicting doom, but understanding our home. It deepens our appreciation for the forces that shaped us and drives our curiosity to explore. The same gravity that could destroy us also holds us together. When you look at the night sky, see it as both a shield and a reminder of our improbable journey. The universe is full of peril and wonder, and the chance to witness it is the greatest gift of all. The cosmic nightmare begins. Today, we are diving into something absolutely insane. You see the planets on your screen, you see the stars, and you probably think it's all beautiful, peaceful, and super majestic, right? Wrong. Today, I'm going to show you that the solar system you think you know is actually a cosmic house of horrors, packed with more terrifying things than you could ever imagine. So buckle up, because what you're about to hear is going to completely change the way you look at the night sky forever. I'm not even kidding. This is some next-level, mind-blowing stuff that will keep you up at night. Think you know the solar system? Think again. We're not talking about cool space facts your science teacher told you about. No, no, no. We are talking about 5 of the most genuinely terrifying, bone-chilling truths about our cosmic neighborhood. This isn't for the faint of heart. If you get scared easily, maybe go watch a video about puppies or something, because we are about to explore planetary hellscapes, deadly radiation fields that would liquefy you in seconds, and cosmic threats that make horror movies look like a walk in the park. This is the real deal, the stuff that scientists know and probably don't talk about at dinner parties. I have spent an insane amount of time with my team digging up the most shocking facts, and I can promise you, by the end of this video, your jaw will be on the floor. We are going to peel back the curtain of space and reveal the absolute nightmares lurking just beyond our atmosphere. I want you to stick around for all 5 facts, because the last one is probably the scariest one of all, and it's a question that has haunted humanity for centuries. This is going to be an absolute roller coaster of cosmic fear, so make sure you are ready for what's coming next. And before we jump into this cosmic abyss, I have a challenge for you. As we go through these 5 terrifying facts, I want you to think about which one freaks you out the most. At the end of the video, go down to the comments and let me know which fact is the absolute scariest. I'm going to be reading every single comment to see what you guys think. Alright, no more waiting around. Let's get right into the first horrifying fact about our solar system. You have been warned. Fact number 1. The sun, our life giver, is a ticking time bomb. Like all stars, it has a life cycle. It's currently burning hydrogen, but that won't last forever. Eventually, it will become a red giant, spelling catastrophe for Earth. As the core contracts and heats up, the sun's outer layers will expand, changing our solar system's structure. Earth will be erased. Total annihilation is guaranteed. The end culminates in our world being consumed by fire. This is about 5 billion years away, but we're on a planet with an expiration date. Alright, moving on to scary fact number 2, and this one is about the biggest planet in our solar system, Jupiter. When you look at pictures of Jupiter, you see this beautiful, swirling giant with its great red spot. It looks majestic, like the king of the planets. But this king is a tyrant, and it presides over a kingdom of invisible, deadly energy that would kill a human being faster than almost anything else in the solar system. We are talking about Jupiter's insane radiation belts. These aren't just some minor hazard. They are one of the most lethal environments we have ever discovered. You see, Jupiter has an incredibly powerful magnetic field, about 20,000 times stronger than Earth's. Our magnetic field is what protects us from harmful solar radiation, creating the Van Allen belts. But Jupiter's is on a completely different level. It's so massive and powerful that it traps an unbelievable amount of charged particles from the solar wind, electrons and ions, and accelerates them to nearly the speed of light. This creates a donut-shaped area of super intense radiation surrounding the planet, a region of space that is an absolute death trap. If you were in a spacecraft like the Apollo missions, and you tried to fly near Jupiter, you would be in for a horrifying surprise. The radiation dose inside these belts is hundreds of times the lethal dose for a human. We're talking about receiving a fatal dose of radiation not in days or hours, but in a matter of minutes. The high-energy particles would blast through the hull of your ship and through your body, shredding your DNA, destroying your cells, and causing catastrophic, irreversible damage to your central nervous system. It would be a swift and brutal death. This isn't just a theory. Every single robotic probe we've sent to Jupiter, like Galileo and Juno, has had to be heavily armored with lead and titanium shielding, like a cosmic tank, just to survive for a little while. Even with all that protection, their electronics are constantly getting fried and damaged by the relentless onslaught of radiation. The Juno probe was specifically designed to fly in a crazy polar orbit that swoops in and out as fast as possible to minimize its time inside the deadliest parts of these belts. That's how terrifyingly dangerous this environment is. The most terrifying thing about Jupiter's radiation is that it's completely invisible. You wouldn't see anything. There are no flashing lights, no warning signs. One moment you'd be looking at the beautiful swirling clouds of Jupiter, and the next, the particles would be silently tearing your body apart on a molecular level. You would feel a sudden wave of nausea, confusion, and pain as your systems began to shut down. It's a silent, instantaneous executioner waiting in the void of space. This invisible field of death is what makes Jupiter so uniquely horrifying. Let's break down the numbers, because this is insane. The radiation dose near Jupiter can reach up to 100,000 rads per day. For context, a dose of about 500 rads is enough to kill a person, so you are being exposed to a dose 200 times the lethal limit every single day. But it gets worse. The most energetic electrons in Jupiter's belts are so powerful that they are constantly creating what's called breaking radiation, or Bremsstrahlung. This is when the electrons slam into a spacecraft's hull, creating a secondary shower of high-energy X-rays and gamma rays inside the ship. So even with shielding, the shield itself becomes a source of deadly radiation. This radiation doesn't just stay close to Jupiter either. The planet's magnetic field is so enormous that it stretches millions of miles into space, all the way past the orbit of Saturn. This is called the magnetotail, and it's like a giant invisible dragon's tail sweeping through the solar system, blasting everything in its path with deadly particles. Jupiter is actively polluting its cosmic neighborhood with lethal radiation. It's not a passive danger, it's an aggressive one. Any future mission to the outer solar system has to carefully plot its course to avoid this deadly region of space. So while we dream of sending humans to explore the outer planets, Jupiter stands as a colossal, radioactive gatekeeper. Before we could even think about getting to its fascinating moons, like Europa, with its potential for life, we would have to solve the problem of surviving a journey through this invisible hell. The technology required to shield a human crew sufficiently from this kind of radiation is far beyond anything we currently possess. Jupiter is the king of the planets, but it's a king that kills any visitor who gets too close. And if you think the space around Jupiter is bad, just imagine what it's like for its inner moons. The four largest moons, Io, Europa, Ganymede, and Callisto, are all orbiting deep inside these deadly radiation belts. They are constantly being bombarded 24/7 by this insane stream of high-energy particles. The surfaces of these moons are among the most irradiated places in the entire solar system. It's a level of radiation that would make the surface of Mars or our own moon look like a paradise in comparison. This has profound consequences for these worlds. Let's start with Io, the closest of the four. Io receives the most intense radiation dose, something like 3,600 rem per day. Again, 500 rem is lethal to a human. This means that if you were to stand on the surface of Io without any shielding, you would receive a fatal dose of radiation in less than a minute. The surface of Io is so radioactive that it's considered completely sterile. The constant blast of particles has likely destroyed any complex organic molecules that might have existed there, making it an incredibly hostile place for life as we know it. Next is Europa, the moon that gets scientists so excited because of its subsurface ocean. But the surface of Europa is also a death trap. It gets blasted with about 540 rem of radiation per day. That means an unprotected astronaut would receive a lethal dose in about 24 hours. Any potential life on Europa would have to be hiding deep beneath its thick ice shell, where the water could shield it from the deadly radiation coming from Jupiter. The surface itself is a sterilized, radioactive wasteland. To search for life, we'd have to drill through miles of ice just to get away from the lethal surface conditions. This radiation has a visible effect, too. The particles slam into the icy surfaces of moons like Europa and Ganymede, knocking molecules apart and changing their chemical composition. It's what gives parts of Europa that reddish-brown color. It's literally the result of the ice being sputtered and chemically altered by the relentless radiation. Jupiter is not just bathing its moons in a deadly energy field, it is actively scarring and rewriting their surfaces. It's a constant violent process that has been happening for billions of years, shaping these worlds into the tortured places they are today. So what does this all mean for the future of space exploration? It means Jupiter is the ultimate barrier. For decades, we've dreamed of sending astronauts to the outer solar system. We have these incredible visions of landing on the icy surface of Europa, drilling down into its hidden ocean, and discovering alien life. Our third scariest fact takes us to Venus, Earth's so-called twin. This planet is absolutely insane. There is pure, unfiltered terror. You're instantly crushed. The atmospheric pressure is over 90 times stronger than on Earth. It's instant obliteration. Even super tough probes don't last long. The surface temperature is hot enough to melt lead. Venus is the hottest planet because of its runaway greenhouse effect. It literally rains highly corrosive sulfuric acid. This is, without a doubt, the most hellish place in the entire solar system. There is virtually no water on Venus. Venus isn't Earth's twin, it's Earth's nightmare. Our solar system is a cosmic shooting gallery, and Earth is a target. We're constantly bombarded by space rocks, most burning up as shooting stars. We're flying through ancient debris from the solar system's formation. Look at the moon, covered in craters from past collisions. The dinosaurs didn't see it coming. 66 million years ago, a 6-mile-wide asteroid ended their reign. The Oort cloud, a distant shell of icy objects, sends comets our way. These long-period comets are nearly impossible to predict, offering little warning. But for the first time, we can see the threat and potentially do something. Planetary defense is now a real field, working to protect Earth. NASA's DART mission successfully changed an asteroid's orbit. We're in a race against time to find threats before they find us. Okay, for our final and possibly most mind-bending scary fact, we have to ask a simple question. Are we alone in the universe? This question has two possible answers, and honestly, both of them are terrifying in their own way. Let's start with the idea that we're not alone. Our galaxy, the Milky Way, has hundreds of billions of stars, and there are hundreds of billions of galaxies in the observable universe. The numbers are so massive it seems statistically impossible for Earth to be the only planet with life. There should be alien civilizations everywhere, right? This leads us to something called the Fermi paradox. The physicist Enrico Fermi basically asked, if there are so many potential alien civilizations out there, why haven't we seen any evidence of them? No radio signals, no giant alien megastructures, no spaceships showing up to say hello. The universe is incredibly old, about 13.8 billion years. There has been plenty of time for civilizations to arise, develop interstellar travel, and colonize the entire galaxy. Yet when we look up at the sky, all we see is silence, an eerie, cosmic silence that is incredibly unsettling. This silence is what makes the idea of alien life so scary. Where is everybody? Are they hiding from us? Or worse, are they hiding from something else? One terrifying possibility is the Great Filter Theory. This theory suggests that there is some kind of universal barrier or challenge that is so difficult to overcome that it prevents almost all civilizations from becoming interstellar. Maybe it's a technological challenge we haven't faced yet, or a natural event like a gamma ray burst, or maybe civilizations just inevitably destroy themselves before they can reach the stars. The scariest part of the Great Filter theory is figuring out where we are in relation to it. Have we already passed the Great Filter? Maybe the leap from single-celled organisms to complex life is the filter, and we're one of the lucky few who made it. Or, and this is the terrifying option, is the Great Filter still ahead of us? Is there some future challenge waiting for humanity that has wiped out every other advanced civilization before us? The silence of the universe could be a warning sign, a cosmic graveyard whispering that our future is doomed. Let's dive deeper into one of the most chilling explanations for the Fermi paradox, the dark forest theory. This idea comes from a science fiction novel, but it's so plausible that it keeps astronomers and philosophers up at night. The theory proposes that the universe is like a dark forest filled with silent hunters. In this forest, every civilization is a potential threat to every other civilization. Because you can never be certain of another civilization's intentions, the safest survival strategy is to remain completely silent and hidden. You don't dare make a sound. Think about it from an alien's perspective. If you detect another civilization, you have no idea if they will be friendly or hostile. If they are hostile, they could wipe you out. Even if they seem friendly now, they could become hostile in the future as they develop new technologies. Because interstellar communication takes decades, centuries, or even millennia, there's no way to have a real conversation and build trust. You are faced with a terrible choice. Risk your own extinction by revealing yourself, or ensure your own survival by eliminating the other civilization before they can eliminate you. According to the dark forest theory, any civilization that is foolish enough to broadcast its existence into the cosmos is like a lost child shouting in the woods. They are immediately revealing their location to every predator in the forest. The hunters, who have been staying silent to survive, will see this new signal as either a naive newcomer or a potential threat. The logical, safest course of action for any of them is to destroy the noisy civilization as quickly and quietly as possible, just to be safe. It's a terrifying game of cosmic survival, where the first rule is to never, ever reveal your location. This puts all our efforts to contact extraterrestrial intelligence, like the messages we sent on the Voyager probes or the radio signals we've broadcast into space, in a terrifying new light. We might not be sending a friendly hello. We might be lighting a giant bonfire in the middle of the dark forest, screaming, "Here we are! We're vulnerable!" The silence we observe in the universe might not be because no one is out there. It might be because everyone else is smart enough to stay quiet, and we're the only ones dumb enough to be shouting. Alright, we've explored the terrifying idea that we're not alone, and that aliens might be hostile or hiding. But now let's consider the other answer to the question, which is, in its own way, just as scary. What if we are completely, utterly alone? What if, in this entire vast, sprawling universe, with its trillions of galaxies and septillions of stars, this little blue-green planet is the only place where life ever took hold? What if we are the only thinking, feeling, conscious beings in all of existence? That is a lonely and horrifying thought. If we are truly alone, it means the entire universe outside of Earth is a sterile, empty wasteland. All those beautiful nebulae, swirling galaxies, and fascinating planets are just meaningless collections of gas, dust, and rock. There is no one else to witness the beauty of a supernova, no one to ponder the mysteries of a black hole, no one to create art or music or science. The entire cosmic story, with all its grandeur and complexity, is playing out to an empty theater. The universe would be a colossal waste of space, and we are its only audience. The weight of this possibility is crushing. It means that all the hope, all the consciousness, all the laughter, and all the tears in the entire universe are confined to this one fragile planet. If we fail, if we drive ourselves to extinction through war or climate change or by failing to stop an asteroid, then the universe loses its only spark of consciousness forever. The light of thought and wonder would go out, and the cosmos would return to being a mindless, purposeless machine. The pressure is immense. The entire meaning of the universe rests on our shoulders. This idea makes our existence both incredibly precious and incredibly precarious. There would be no advanced alien race to come and save us from ourselves. There would be no cosmic wisdom to inherit from older civilizations. We are on our own, a tiny, lonely miracle in an endless, silent void. We have to figure everything out for ourselves, and if we get it wrong, that's it. Game over for the entire universe's one shot at consciousness. That level of cosmic responsibility is, frankly, terrifying. So, which is it? Is the universe a dark forest teeming with silent predators? Or is it a vast empty desert where we are the only oasis of life? The scariest part of all is that we simply don't know, and we may never know. We are trapped in a state of profound cosmic uncertainty. We send our signals out into the void, and the only thing that comes back is the echo of our own questions. This uncertainty itself is a source of deep anxiety. Are we shouting into an empty room, or are we alerting a hidden monster to our presence? This is the ultimate cosmic horror. It's not about jump scares or monsters in the traditional sense. It's about the dawning realization of our own insignificance in the face of the vast, unknowable cosmos. The universe does not care about us. It operates on principles and timescales that are beyond our comprehension. Whether it is full of life or completely empty, either reality forces us to confront some very uncomfortable truths about our place in the grand scheme of things. We are adrift in a cosmic ocean, with no map and no idea if there are other ships out there, or if they are friend or foe. Every night when you look up at the stars, you are looking at this great mystery. Every single point of light could be a sun with its own planets, its own life, its own civilizations with histories a billion years longer than ours. Or it could just be a sterile ball of burning gas, surrounded by dead rocks. We have no way of knowing. This forces us to live with a fundamental, existential dread. We are like characters in a story who don't know the genre. Is this a story of heroic first contact, a tragic story of lonely survival, or a horror story where we are the next victims? Ultimately, the search for alien life is a search for ourselves. It forces us to ask the biggest questions. What does it mean to be human? What is our purpose? And what is our future? The answers could be magnificent, or they could be the most terrifying thing we ever discover. The fact that the universe holds these secrets, and may never give them up, is the fifth and final scary fact about our solar system and the cosmos beyond. The truth is out there, but it might be a truth we don't want to know. And that's it. 5 of the absolute scariest, most terrifying facts about our solar system. From our own sun turning into a planet-eating monster, to Jupiter's death ray radiation, the hellscape of Venus, planet-killing asteroids, and the chilling silence of the universe. It's a miracle we're even here. I don't know about you guys, but I'm going to need... Something strange is happening with our planet. Today, July 8, 2025, is the shortest day ever recorded. Earth has suddenly picked up its pace, spinning faster than ever before. It's a tiny change, just a fraction of a second. But in the cosmic scheme, it's huge. For millions of years, Earth's rotation has been slowing down, not speeding up. Our atomic clocks, the most precise instruments we have, are now telling us the opposite. This isn't just trivia. It's a scientific mystery. The forces that govern Earth's spin are ancient and powerful. When a pattern that's held for eons suddenly reverses, it means something fundamental is shifting. Imagine if the sun rose in the west one morning. It's that level of surprise. The Earth is speaking to us in the language of physics, and we need to listen. So, what does this mean? The balance of forces acting on our planet has been disturbed. Earth isn't just a rock in space, it's a dynamic living system. Its molten core, shifting plates, oceans, and atmosphere all interact in a complex dance. This sudden speed-up is a clue, a breadcrumb leading us to a deeper understanding. Even our own planet holds secrets we have yet to uncover. The shortest day ever recorded is more than a number. It's a cosmic wake-up call. The story of Earth's spin just got a new, unexpected twist. To understand why a faster Earth is so weird, you have to look at the moon. For billions of years, the moon's gravity has acted as a brake, slowing Earth's spin. The moon's pull creates tidal bulges in our oceans, dragging against Earth's rotation. This tidal friction steals a bit of Earth's rotational energy, making our days longer over time. When dinosaurs roamed, a day was about 23 hours. Go back further, and it was even shorter. As Earth slows, the moon drifts farther away, about 1.5 inches each year. This gradual slowdown is the baseline built into our models of planetary science. That's why the recent speed-up is so shocking. It's not just a blip, it's a reversal of a multi-billion-year trend. The brakes haven't just been released, it's as if someone hit the accelerator. Our understanding of Earth's rotation is being challenged. The moon's steady influence is no longer the whole story. Something new is at play, and it's rewriting the rules. Scientists are left with a cosmic whodunit. The question isn't just why Earth is spinning faster, but what it means for our understanding of the planet. The dance between Earth and Moon just got a lot more interesting. For decades, we've watched Earth's rotation slow and added leap seconds to keep our clocks in sync. But around 2020, scientists noticed a reversal. Earth stopped slowing and started speeding up. Today marks the shortest day since atomic clocks were invented. The moon's tidal braking hasn't changed, so something else must be at work. This isn't a minor discovery. It's a fundamental challenge to our understanding. Planetary changes usually take millions of years, but this has happened in just a few. Whatever's causing it is powerful and happening right now. Our models can't explain it, making this a true anomaly. When nature throws a curveball, it's a chance for discovery. Scientists are scrambling to understand what's happening, running new simulations and re-examining data. The puzzle is bigger than just a faster spin. It's about the interconnected systems of our planet. From the core to the atmosphere, Earth is more dynamic and mysterious than we thought. The search for answers is on. Where do we look for the cause of this speed up? Deep inside the Earth, our planet's core, mantle, and crust interact in complex ways. One theory, changes in the flow of the liquid outer core could be altering Earth's rotation. The Chandler wobble, a small, irregular movement of Earth's poles, might be involved. Climate change is another suspect. Melting ice redistributes mass, subtly shifting Earth's shape and spin. Major earthquakes can also shift enough mass to affect rotation, though not usually for long. It's likely a combination of factors. A perfect storm of core changes melting ice and seismic activity. Scientists are using satellites and seismic sensors to untangle these effects. The clues are hidden deep within the planet. Earth is a restless, dynamic system, and this mystery is a reminder of that. The answer may lie in the interplay of forces beneath our feet. The search continues, with every new clue bringing us closer to understanding. The planet's secrets are waiting to be uncovered. This speed-up isn't just a scientific curiosity. It has real-world consequences. We've long used leap seconds to keep atomic time and astronomical time in sync. With Earth spinning faster, we may need to subtract a second, a negative leap second, for the first time ever. That means the clock would skip a second, jumping straight to midnight. This is a nightmare for computer systems and global networks. GPS, financial markets, and data centers all rely on precise, continuous time. A missing second could cause errors, crashes, or even data corruption. Most systems assume time only moves forward. Losing a second could break software worldwide. The debate over leap seconds has suddenly become urgent. The need for a negative leap second is unprecedented. It's a reminder that our digital world is tied to the unpredictable physics of our planet. As Earth's spin changes, so must our technology. The challenge is real, and the world is watching. The next leap second could be a leap into the unknown. Here we are on the shortest day in recorded history. This tiny anomaly opens up a universe of questions. Earth isn't a static backdrop. It's a living, dynamic world. This event forces us to rethink what we know about our planet and its rhythms. If Earth's rotation can change so quickly, what about other planets? Could similar shifts affect their climates, magnetic fields, or even their ability to support life? Every secret we unlock about Earth helps us understand the cosmos. Solving this mystery will push science to new heights. We must listen to what the planet is telling us. The faster spin is a message, not a problem, a clue to deeper physics. Today, Earth has given us a new mystery and a new chapter in its story. The cosmic dance continues, and we're lucky to have a front row seat. Imagine standing outside on a perfectly ordinary sunny day. Feel the warmth, see the vibrant colors around you. It's July 9th, 2025, a seemingly unremarkable date in the grand scheme of things. The world feels normal, predictable, safe. Just another day unfolding as expected. You feel the gentle warmth on your skin, a comforting reminder of the sun's constant presence. You hear the joyful sounds of children laughing, their carefree energy filling the air. Life is moving as always, a bustling tapestry of everyday moments. Suddenly, without warning, without any discernible cause, the sun vanishes. It's simply gone. There's no cataclysmic explosion, no ominous sign in the heavens, no prior warning. It's just inexplicably gone. The sky remains blue, but something profound has shifted. For a few precious moments, nothing outwardly changes. The world continues as if nothing has happened. The sky stays a vibrant blue. The air remains warm and inviting, bathed in the afterglow of a sun that no longer exists. People continue their daily routines, completely unaware of the impending cosmic shift. This is the deceptive calm before the storm, a cosmic illusion masking a terrifying reality. The universe's laws are strict and unyielding, and they dictate the unfolding events. The finite speed of light means we don't know instantly about this catastrophic event. Information travels, but it takes time. The last vestiges of sunlight are already on their way to us, carrying the warmth and light of a sun that no longer shines. Those final rays are taking approximately 8 minutes and 20 seconds to bridge the vast gulf of space and reach our planet. In that brief window of time, life continues its familiar rhythm, oblivious to the impending darkness. Coffee is sipped, providing a momentary jolt of energy. Appointments are kept, commitments fulfilled in a world about to be irrevocably altered. No one suspects the terrifying truth lurking just beyond the horizon of perception. But the clock is relentlessly ticking down, marking the final moments of an era. The final wave of gravity and light, the echoes of a vanished star, is racing inexorably toward us, carrying the news of our impending doom. Our world, as we know it, is poised on the brink of a transformation that will redefine the very meaning of existence. The great cosmic unplugging has occurred, severing our connection to the life-giving star, and we are mere seconds away from feeling the full, devastating consequences of that unimaginable event. What would you do with your last 8 minutes of sunlight if you knew they were your last? How would you spend those precious moments? But would you even notice the subtle shift, the imperceptible fading of the light? Probably not. The sun's sudden disappearance is so far beyond our realm of experience, so utterly unimaginable, that we have no instinct to prepare for it, no primal fear to warn us. Yet in this chilling scenario, the countdown has irrevocably begun, ticking away the final seconds of our solar-powered existence. The last photons and the final whispers of gravity from the sun are almost here, carrying with them the harbinger of a new terrifying reality. Our planet is teetering on the brink of a cataclysmic transformation, a fundamental shift that will redefine the very essence of existence. The cosmic curtain is about to fall, plunging our world into an unending night. Darkness is coming, an all-encompassing darkness that will forever alter the fate of humanity. For 8 minutes and 20 seconds, we continue to live as if nothing has changed. We bask in the ghost of a dead star, feeling its warmth, unaware that the source is long gone. The light that caresses our skin is a memory, a cosmic echo. Light and gravity, the fundamental forces that shape our reality, both travel at the speed of light, a universal constant. So in a strange twist of fate, Earth orbits a sun that's already gone, a celestial dance with a phantom partner. We are bound by the gravity of a star that no longer exists. Then, in an instant, everything changes. The familiar world we know is about to be irrevocably altered. Daylight vanishes. Not a sunset, a gradual fading, but a switch flipped off. An abrupt and absolute end to the day. The world is plunged into a darkness deeper than any night we have ever known. A void where even shadows cease to exist. The moon disappears, its gentle glow extinguished, leaving only distant stars, cold and indifferent witnesses to our plight. At the same moment, gravity's grip is released. The invisible tether that held us to the sun is severed. Earth flies off its orbit, no longer bound to the familiar path around our star, becoming a rogue planet hurtling through space, a cosmic wanderer lost in the vast expanse. We are no longer part of the solar system. We are castaways, adrift, alone, hurtling into the unknown. The final sunset has come and gone, marking the end of an era. Our journey into the endless night begins, a voyage into the cold, unforgiving void. The universe is now our only companion, a silent, indifferent witness to our fate. Panic erupts as the world is plunged into sudden night. Power grids fail, communication collapses, and only artificial lights remain. The stars shine brighter than ever, but the cold sets in fast. Temperatures plummet, deserts freeze, tropics shiver. Within days, the planet becomes an icebox. Oceans begin to freeze and photosynthesis stops. Plants die. Food chains collapse. After a month, Earth is a frozen wasteland. Surface life nearly gone. Humanity retreats underground, seeking warmth from the planet's core. Our vibrant world is now a silent, dark ice ball hurtling through space. Months pass, and the cold intensifies. Surface temperatures drop to minus 400 degrees Fahrenheit, cold enough to freeze the air. The atmosphere condenses and snows down, leaving a vacuum above. Oceans are sealed beneath miles of ice, but deep below, geothermal heat, keeps some water liquid. Around hydrothermal vents, life clings on bacteria, tube worms, and strange creatures. These deep-sea oases become the last sanctuaries of life. Humanity's only hope is to mimic this geothermal-powered bunkers deep underground. We create closed-loop ecosystems, powered by the planet's fading warmth. Survival means adapting to a claustrophobic, sunless world. The sun's disappearance, a celestial event of unimaginable scale, triggers the greatest extinction in Earth's history, a cataclysm that reshapes the very fabric of our planet. The delicate balance of ecosystems is shattered. Plants die, deprived of the life-giving energy they need to survive. Herbivores starve, their food sources gone, their populations decimated. Carnivores follow. Their prey vanished. They too succumb to starvation. Life's web unravels, thread by thread, until the entire tapestry of existence is torn apart. Only extremophiles, organisms thriving in darkness and heat, find refuge in the most inhospitable environments. They survive near hydrothermal vents, where the Earth's internal energy provides a lifeline. For them, life goes on, a testament to the resilience of nature. Their world remains unchanged by the loss of the sun, a hidden oasis in a dying world. Humanity must become a species of miners and engineers, adapting to a world without sunlight. We must begin living in subterranean cities, carving out a new existence beneath the surface. Artificial lights replace the day, illuminating our underground world. And stories of the sun become legend, whispered tales of a world bathed in light. Children are born without ever seeing the sky, their lives confined to the artificial glow of the underground. Our world is now digital memories, a collection of data and simulations. And geothermal hope, the Earth's internal heat providing the energy we need to survive. The deep ocean and underground become the last cradles of life, sanctuaries for those who can adapt to the darkness. We adapt or we vanish, leaving behind only echoes of a world that once was. The sun's disappearance throws the entire solar system into chaos. Planets and moons fly off into space, each on its own lonely path. Gas giants and their moons may harbor life for a while, warmed by internal heat. But over eons, even these worlds drift apart, lost to the galaxy. Earth becomes a silent wanderer, a frozen relic of a lost solar system. Yet hope endures in our curiosity and resilience. We study the stars, preserve our knowledge, and strive to survive. The sun may be gone, but our journey among the stars continues.